Hello students, today I am here to teach you chapter 2 in your textbook that's called Indices and Logarithm 1. So chapter 3 is Indices and Logarithm 2. So we'll see what are indices and logarithms. First we'll discuss what are indices. Now we'll take this one. We'll multiply 7 5 times. How can we write down as a single notation? So here 7 ones, another one is there, another one. How many times we are multiplied by 7? We multiply 5 times. So we can write this number as 7. 5 times we write as a superscript of 5. So here when you take this number, we call this one the power of the number, or there are so many names for that, power or index. Index is a singular term, indices is plural term, and then another name is there for power, exponents. So here if you see exponents or power or index, it's the same thing. So what do you call this number? We call this number as base. So here when you have same digit multiplying several times, we can write down as a single term. So we call this one is the index notation. So if you are asked to write down any value in index notation, we can write thinking about the power and the base. Power means index. Now we'll look at several examples. Okay, so here already given the index notation and you are asked to expand it. So how can we do 7 to the power 3? 7 is the base, 3 is the index. So we can write this one as 7 3 times. What about this one? Minus 10 whole thing to the power 4. So that means we are multiplying minus 10 4 times. What about this one? X to the power 5. X to the power 5 means x 5 times. What about this one? 5 is there and a to the power 3. Here we only consider power 3 for a. So 5 just write down as it is, but a you get 3 times. What about this one now? This and this totally different. Here you get brackets also. That means both these numbers you have to multiply 3 times. So here what is 5a whole thing to the power 3? That means 5a times 5a times 5a. What about this one? 10 to the power 4. So what's that? 10 4 times. This one, only power for x, not for 3. So here we can write 3 and 2 x's, 3 times x times x. This one you see, brackets. That means whole thing multiply 3 times. So here we can write 5p and another 5p. What about this one? 7x squared y. This means 7 is there, x 2 times and y once. This one, how can you expand and write? I can write this one as 3a squared. A squared means a twice. And then you get b. This one, 7xy. That means 7 times x times y. So you need to understand what is the power means, index means. You repeat the same thing according to the power. Now we'll take already expanded version is there and we need to write as a single index notation. So here when you take 3, how many times are there? 1, 2, 3, 4, 5. So how can I write this one? 3, 5 times. Now what is 3 means? What's the power? Power 1. So here 1, 1, 1, 1, 1. Look at carefully what happens there. Same base. You get same base here. 1, 2, 3, 4, 5. You get 5 there. And try to observe this also. 9 to the power 5. That means 5 9s are there. 9 squared means another 2 9s. Altogether, how many 9s are there? 1, 2, 3, 4, 5, 6, 7. So you get 9 to the power 7. What can you see? Same base you are getting and look at the powers 5 and 2. You get 7. What's the connection between 5, 2 and 7? Can you identify? Yes. When you add these two, you see you are getting this number. Add all these numbers together. 1 plus 1 plus 1 plus 1. You get 5. So we see a pattern. When you add the powers, you are getting that number. Now, by looking at this pattern, what do you think this number is? Same base you are getting. What should be the power now? 8 plus minus 3. So what is 8 plus minus 3? 8 plus minus 3. That means we are adding the powers. So you get 8 minus 3. You get 5. What about this one? What can you see? You get same base. Minus 4 is one power. Adding minus 2 to that. So when you add minus 4 and minus 2, what's the answer? You get minus 6. What about this one? You get same base, x, a and 3. So how you add a and 3? Those are not like terms, so you have to write as it is, a plus 3. This one, same base, P and Q as the powers. So you are adding the power. So here, from this, what you observed, when you get multiplication with same base and different powers, you add the powers. So we can write general form for that. When you get any base with different powers, I'll take a to the power n, a to the power n. When you multiply these two, you get same base. The power becomes the addition of these two powers. So this is the first law you have to remember. So what's the first law? Laws of indices. The first law of indices is when you get multiplication with same base and different powers, you get same base with addition of the powers. So here I'll write down the first law. When you multiply same base, different powers, you get addition of powers. With the same base. So remember the first law. This should be multiplication, and same base, when you multiply two numbers with different powers, you add the powers. Now we'll look at division. Earlier we did multiplication. What about division? So we'll just take one example and see what happens to this one. 3 to the power 5. Now you know what is 3 to the power 5 means. 3 5 times. Divide by, this is division, 3 squared. What is 3 squared? 3 twice. Now this is normal division. You can cross out the common terms. I can cross out this 3 with this one, this 3 with this one. So what is remaining? You get 3 to the power 3. Now observe the pattern. You get division, same base, 5 and 2 with 3. How you get 3 with 5 and 2? What's the relationship? You can see 5 minus 2 is 3. Again, we'll do another one and see. 9 to the power 6. 1, 2, 3, 4, 5, 6. 6 times you have to multiply 9. What about 9 to the power 3 means? You have to multiply 3 times. Now cross out the common terms. I can cross out this 9 and this 9. So what's remaining? 9 to the power 3. Now see the relationship between 6, 3 with 3. What's the relationship? We see that when you subtract these powers, you are getting the other power. Here 5 minus 2, you are getting 3. So using that pattern, what can you write here at once? When you get division, all these are division. With same base, different powers, you subtract the powers. So here what we can do? 4 minus 2. So you subtract the two powers. So what happens there? 5 minus minus becomes plus. 5 plus 2, you get 6. So here you get 10 to the power 6. What about this one? You get same base, division. So what happens? You get x. So what's the subtraction now? Minus 3 minus 3. What happens? Minus 3 subtract minus 3. This becomes 0. So you get 0 here. What about this one? Same base division you are getting. You get the same base. What about the powers? You subtract the powers. So you get a minus 3. This one, same base division. What's the power you are getting? This is a and b. You are getting a minus b. So what's the second law here? Second law in indices is when you get any base with different powers and when you are dividing by another index value, what happens to the answer? You get the same base, but the power becomes subtraction. So this is the second law that you have to remember in indices. So here I'll put this is as number 2. So how can I write down the law? When you get same base, different powers, with division. Now it's division. You need to subtract the powers. So here we subtract, and this is division. So that's the second law in indices. Now this is something different now. Earlier we did when you multiply two index notations, what happens, and when you divide, what happens. Now you get brackets. So here we'll try to first do a sum. So what is 7 to the power 3? We'll try to write down inside number. This means 7 3 times and the power is there. Now we know what's power 2 means. You're getting same set twice. So I can write this one as 7 into 7 into 7 once. That's one set. Again 7 into 7 into 7. Now, how many 7s altogether? You get 1, 2, 3, 4, 5, 6. Now try to observe the pattern. What you see? This is 6 now. This is 3 and 2. What's the relationship? We'll do another one and see the relationship. 9 to the power 4. 9, 9, 9, 9, 4 times. And then you are repeating twice. So repeating twice means you are multiplying with another set. What happens? How many 9s are there? 1, 2, 3, 4, 5, 6, 7, 8. 9 to the power 8. Now try to observe the pattern. Earlier 4 and 2 with 8. What's the pattern? You can see. 3 and 2. How you get 6? 3 times 2. How you get 8 with 4 and 2? 4 times 2 you get 8. So here we see when you get brackets, the relationship between those powers becomes multiplication. So with that pattern, how can I write the value at once? There are brackets and here you get two numbers there. So what you do? Base is 10. Base is not changing. Only the power. So power becomes the multiplication of the two numbers. 3 times minus 2. So what is 3 times minus 2? You get minus 6. Now try this one. You get two numbers. 4 times 2 over 3. So what is 4 times 2 over 3? Just multiply the numerator. You get 8 over 3. So you can write this one as 8 over 3. What about this one? You get brackets. Here also you need to multiply the powers. So power is a and 3. So 3 times a or a times 3, you get 3a. This one, base is y. What are the two powers given? P and Q. So what you do here? You multiply the two powers. So what you get here? P, Q. So what's the third law in indices? Third law says when you get any number with a different base and you get brackets and another power. Power of a power. We call power of a power. So here what happens? You get same base but we multiply the power. So what's this rule? This is law number 3. So here what it says, when you get power of a power, when you get, I'll write down that, power of a power, you multiply the powers. So here we do multiply. So remember those 3 laws of indices. Now something different. So 9 to the power 0, 7 to the power 0. We'll see what we get. I'll take an example for this. I can rewrite this one as 9 to the power 3 divided by 9 to the power 3. Because according to the second law, same base with different numbers division, you subtract the power. So here 3 minus 3, you get 0. So I am writing any 0 in this form. Then if I am doing normal division, what is this? 9 3 times and again divide 9 3 times. When you do normal division, what happens? 9 get cancelled out, one other 9 also get cancelled out. Here you are getting 1 time 1 time 1, you get 1. So what's the number you are getting? You are getting 1. Again I can write this one 7 to the power 0. I can take any power and write down this is 7 to the power 5 divided by 7 to the power 5. Because according to law number 2, when you get division, you subtract the powers. 5 minus 5, you get 0. So when you do normal division, 7 5 times, 1 2 3 4 5, again 7 5 times. So when you cancel out all these, you are getting 1. So what's the pattern you observe? When you get any number to the power 0, you get 1. Now, this is a number, any number, power 0. What do you think the answer? At once, you should be able to write down the answer. So, any number to the power 0 is 1. Any number, minus 1 is any number. To the power 0 is 1. What do you think about this? 0 to the power 0. Do you think that you are getting 1? No, this number is not defined. So here you can apply this law for any number except 0. So here what's the law? we are using any number to the power 0 is always 1, but a cannot be 0. So this is your fourth law of indices. This is the fourth law. So that's an easy one. So when you see 0 as a power, you can think about getting 1. Now we'll look at something like this. Now all these are negative powers. So we'll try to find out a relationship between negative powers and positive powers. So here, look at the first one. First example, 3 to the power 2 divided by 3 to the power 5. So when you use second law, what is the second law? Says when you have same base division, what you do, you subtract the power. So we'll use that law here. So when you use that, you can write 3 to the power 2 minus 5. You subtract the power. So what you get? 3 to the power 2 minus 5 becomes minus 3. So here you get minus 3. How can I write this number? And also when you simplify this one, what I can write? I can write 2 3's and 5 3's in the denominator. When I simplify, what you get? I can cancel out this 3, this 3. So what is remaining? I get 1 in the numerator, 3 3's in the denominator. Now look at carefully this and this. What happens? Same base. Earlier it was minus 3 power. Now positive power. But this is in the numerator and this is in the denominator. If I write this one as 1, nothing happens now. So what happens there? Change the numerator and the denominator and you get sign also different signs. Now by looking at that pattern, what can you say about this one? How can I write any negative power to a positive power? You take the reciprocals. What is reciprocal means? Flipping the numerator and the denominator. So here what you do, look at the numerator and the denominator, you are flipping. 1 goes up, 5 goes down. This negative power becomes positive power. Here, what happens? This is the number. So here, this is like this over this. So you are flipping, taking the reciprocal. 1 goes there, minus 3 to the power 2 goes to the denominator. Now try to write down x to the power minus 5 as a positive power. What happens? Take the reciprocal. That means x to the power 5 goes down. Minus 5 becomes now positive 5. What about this one? Minus x is there as a power. So flipping numerator and denominator, you get a to the power x. This one, flipping the numerator and the denominator, y goes there as a positive power and 1 here. So what's your fifth law? So when you get any number to the power negative, you can write as a positive power by taking the reciprocal of that. So here you get positive power there. So this is your fifth law. So I'll write 5 here. So what it says, any negative power becomes positive power by taking the reciprocal. So reciprocal means upside down. So we discussed 5 laws of indices now. Now look at these ones. Now the number index form is in the denominator. So we need to think about how we can write down in the index form in the numerator. So we'll take this example and see. First one, 1 over 7 to the power 5. Okay, so here how can I write 1 in terms of base 7 from third law? What's the third law? Any number to the power 0 is 1. So here using that, how can I write 1? I can write this is as 7 to the power 0. Then use second law. When you are dividing numbers, what happens to the power? You subtract the power. So this becomes, using second law, 0 minus 5. So what is 0 minus 5? You get minus 5. Now see the relationship. What happens? When you get positive any power in the denominator, you can convert to the numerator value by taking the same power, but the signs are different. Pluses becomes minus. If it's minus there, it becomes plus. Now using that pattern, what do you think? This one. Now 6 to the power minus 3 in the denominator. So what happens? The number now goes up, but you're taking positive power 3. So you get 6 to the power 3. This one, if you want to take it up in the numerator, what you do? You take the reciprocal. So minus 9 goes up as the power 2. This one, x to the power minus 3 in the denominator, how can I write as a positive power? I can write in the numerator, minus 3 becomes plus 3. This one again, the index value is in the denominator. So what I can do, I can take it up by taking the positive power. Here also I can take this number in the numerator with a positive number. So what is the law number 6? Law number 6 says when you get 1 over any number to the power negative power, a to the power minus m, you can convert to the positive power by taking the reciprocal. So this becomes a to the power a. So that's your 6th law. So what is the 6th law? It says any negative power in the denominator becomes positive power by taking it to the numerator. So here remember that law as well. Now we'll apply those two laws, law number 5 and 6. What it says, when you get any negative power, you can flip and make it to positive power. So here when you use law number 5 and 6, how can you write down the answer at once? I can take 7 to the power minus 3 down as positive power. Here 5 to the power minus 2 in the denominator. So here 5 to the power minus 2 you can write as a positive power by taking it to the numerator. So 5 to the power positive 2. So here you can write without positive 5 squared over 7 to the power 3. This one, how can I write this one? Negative power, I can take it down and write positive power. Here, negative power in the denominator, I can take it up and write positive power. This one, power is only for x, not for 2. Here also, power only for y, not for 7. So, here 2 and 7, we have to write as it is because there is no negative power for those two numbers. Only flipping x to the power 3. X to the power 3 goes down and y to the power 2 goes up. This one, how can I write? Negative power is there. So I can take it down and this one I can take it up. This one, A and A, B. Now here you can use power of power law. So what you call power of power? Here without taking minus 3 first, I can write A, this is like 1, B 1. So you have to consider power for both. So you get A to the power minus 3, B to the power minus 3. Now you can flip. So when you are flipping, what happens? A to the power 3 goes to the denominator, B to the power 3 goes to the numerator. Now we'll see another way of writing indices. Here, what is this symbol? We know that's a square root symbol. Here, there's a small 2, but normally we don't need to write down 2. So without that also we consider as the number 2. That's the square root. So if you put 2 or without 2, it means square root. Now, how can I write this one in index notation? Do you know what it means? When there's a small 2 outside, we say square root. If it's 3 outside, cube root. So here square root means you have to remember that's power half. Another thing you have to remember when you get any square root, so you have to remember this is always power half. So how can I write this one? 2 is here very small 2. So that means square root of 7. How can I write this in index notation? I can write as 7 power half. What about this one? A is the number inside. Square root means power half. Here also 2 is there. X to the power 3 is there. Then consider power half. Then if you want to simplify further, what's the law we have to use? Power of a power. So power of a power means you multiply the power. So finally you are getting x to the power 3 over 2. 3 times half is 3 over 2. Now when you look at all these, how can I write down this one? So here instead of 2, this is now y. So here 2 means square root, 3 means cube root, 4 means fourth root, fifth root. So likewise, if it's y, we say yth root. So yth root, how can you write? A to the power x is the number you are getting. This one is 1 over y. Here 2, look at the pattern. If this is 2, 2 goes here to the denominator. 2 goes there. So y is there. Y should be in the denominator. So here, what's the pattern you get? If this is any number, we'll say m to the power nth root, small n there, how can I write down the number? You can write a to the power m, and nth root means this goes to the denominator, a to the power m over n. So remember this one. When you get any nth root, how we can write down the number in index notation. Now we'll look at these numbers and see how can we write down this one in radical form, the other way around. Earlier we had a radical form and you are asked to write in index notation. This one, other way around. How can we do that? 2 over 3 there. So I can separate this one as p squared and 1 over 3. Is that okay? Because according to the power of power, you multiply the powers. So the fraction is 2 over 3. So here 2 into 1 over 3. Now what is 1 over 3 means? This is the cube root value. So I can write with the other notation this symbol, and inside I can put p squared. 1 over 3 means cube root of p squared. What about this one? I can rewrite this as a squared and power 1/3. What is 1/3 means? Cube root. I can write this one as a squared cube root of a squared. This one, how can I write? I can write m to the power minus 2 first and think about 1/3 as the power, because the power is minus 2 over 3. So what you get here? M minus 2, m to the power minus 2, and take the cube root of that. What about this one? Try to write down. Now it's not cube root. Now this is 4 is in the, now you get 4 in the denominator. That means fourth root. How can I write this number? I can write y to the power minus 3 and 1/4 there. So what is 1/4? Means fourth root of y to the power minus 3. Now try to write down this one. This one, first you are getting a negative power. Apply the previous law. We'll write this in positive power. So you can take it up and write 3/5. Negative power becomes positive power by taking the reciprocal. So when you write down that, how can you write in the radical form? this is x cube, and you need to take fifth root because the denominator value is 5. So here basically what we did, when you get any number to the power m and n, you can write this one in radical form as a to the power m with nth root. So remember this pattern. Now we'll apply the pattern we found in these questions. So you are asked to write down these radical forms in index notation. So here nothing mean 2 square root. So here we can write straight away this is as m to the power minus 1 and power half. So when you multiply these two, what you get? You get m minus 1 into half becomes minus half. So m to the power minus half. What about this one? You get 3 outside, that means cube root. So cube root, how can I write? X to the power minus 1 power 1 third. So when you simplify, when you multiply these two together, you get minus 1 over 3. This one, I can first write this one as index notation. So what is nothing means? Square root. So what's the power? You get 3 over 2. Now if you want to convert to a negative power, what you do? You take the reciprocal. So reciprocal is x, the power, positive power becomes negative power. So negative 3 over 2. Now look at carefully this one. You get small 3 and 2 separately. So 2 means just 2 we have to write as it is. This one, this part we can write as x to the power minus 2 is there. And here 3 means cube root. So cube root means 1/3 is the power. Now when you simplify, what you get? 2 is there. Here power of a power means you multiply the powers. So x minus 2 times 1/3, you can write minus 2 over 3. This one, now try. 5 is a big 5. That means not fifth root. If you get small 5, then that's fifth root. So what's this number? 1 over 5 is there, already there. This one you can write as a power. A. Nothing means square root. So you can write minus 3 over 2. That's the square root value. So if you want to rewrite this one in the numerator, what you do? You can't take 5 up because 5 is just a number in the denominator. So what we do? We keep 5 in the denominator and you can take this one to the numerator. So when you take negative power to the numerator, what happens? I can write a to the power positive 3 over 2. So here answer becomes a over 3 over 2 over 5. Now we'll look at what are the laws of indices. We did 7 laws. So we did, what's the first one? Any base with different powers multiplication, what you get? You get same base, you add the powers. That's the first law we did. What's the second law we did? Same base, different powers division. What you get? We subtract the powers. Then what's the third law? When you get any power of a power, what you do? You multiply the powers. What's the fourth one? Any base to the power 0, you get 1, but a cannot be 0. What's the fifth one we did? Any negative power, you can convert to a positive power by taking the reciprocal. What's the sixth law we did? We did when you get any negative power in the numerator, you can write as a positive power by taking it to the numerator. So a to the power m. And what's the last one we learnt? We learnt how to write down the radical form to index notation. So here, if a to the power m with nth root, how can we write down the number in index notation? A, you are getting m over n. So these are the laws of indices you have to remember. Now we'll try to apply these laws in several examples. So you are asked to find out the values. So the index notations given and you need to find out the value. So what we can do? We have to apply several laws. Now here, what's the power there? 2 over 3. And we need to think about how we can write 27 as a power of a number. Now, if you have 3 in the denominator, think about how you get power 3. What's the number to the power 3 is equal to 27? What's that? Any number to the power 3 should be 27. Is it 2 times 2 times 2? You get 8. 3 times 3 times 3? You are getting 27. So what's the power? We can write 27 as 3 to the power 3. And we know 2/3 is already there. Now what's the law we have to use? This is power of a power. So what you do? You multiply the powers. So here what we can do? We can multiply 3 with 2/3. When you do that, we see 3 get cancelled out and you get power 2. So what is 3 squared? 3 times 3, you can find out the answer as 9. So here, using laws, we can easily find out the solutions. Now think about 125. And here 3 is there in the denominator. So that means you have to think about any number to the power 3 should be 125. Think about 4 times 4 times 4 is not 125. What about 5 times 5 times 5? So 5 times 5 times 5 you get 125. So instead of 125 I can write 5 to the power 3. And then you get 2/3 here. When you multiply the powers, what happens? 3 get cancelled out. 5 squared. What is 5 squared? You get 25. Now try 32. But here the denominator value is 5. So you have to think about any number to the power 5 should be equal to 32. So think about 2. 2 times 2 times 2 times 2 times 2. You are getting 32. So I am writing 32 in terms of 2 to the power 5. Then I can multiply the powers. So what happens when you multiply? 5 get cancelled out and you get 2 to the power minus 3. But we don't know what is 2 to the power minus 3. Then you have to apply the other law. When you have negative powers, how can you convert to positive powers? So this is in the numerator. You can take it to the denominator. So how can I write? I can write same thing as 1 over 2 to the power 3. So what is 2 to the power 3? Now we know how to find out 2 to the power 3. 2 times 2 times 2. You get 1 over 8. This one. Here you can first apply the power rule. So here consider outside power for all the numbers inside. So here first thing I can write, minus 2 is there, multiplied by minus 3 over 2, as well as the denominator also multiplied by minus 3 over 2. That's the first step you can do. Then try to simplify. 2 and 2 get cancelled out, and 2 with this 4 you get 2. Now multiply, you get a to the power minus 1 into minus 3. You get positive 3. What about the denominator? Minus 2 times minus 3. You get positive 6. So here I can write down a to the power 3 over b to the power 6. What about this one? First, you have to consider this power for both. So write down that 27 minus 2/3 and 8 minus 2/3. Now, how can we simplify? When we have negative something like fractions, we don't know the value. So you need to find out 27 in terms of any number to the power 3. What about here? Here denominator is 3. So 8, how can you write as a number to the power 3? So what's the number? We already did before. What is 27? 3 to the power 3. So you can write 3 to the power 3 times minus 2 over 3. So what about 8? 8 is, which number to the power 3 is 8? 2 to the power 3. So here you can write 2 to the power 3 into minus 2/3. Now simplify. You get 3 get cancelled out, 3 get cancelled out. You get 3 to the power minus 2 over 2 to the power minus 2. Still we can't find the value. So what is the next law we can apply? We can convert to a positive power. So how we do that? Flipping numerator values, flip to denominator values as a positive power. This one flipping to the numerator with a positive power. Then what is 2 squared? 2 squared is 4. What is 3 squared? 3 squared is 9. So we can easily find out any negative fraction or any power, and we can find out the answers by using laws of indices. Now we'll take this one. 16 1/3 and 54 1/3. Do you know this is any number? First we can simplify. 16 and 54, we can see common term is 2. So what's the first step we can use? Before we applying laws, we can just simplify this. I can divide this by 2 and write 8. What about this one? 54 divided by 2, I get 2 times 2, 5. Plus this one, I get 27. Now try to think about this number 1/3 and this number 1/3. So I'm taking the power for both the numerator and the denominator. Now think about how you get 8 as power 3, how you get 27 as power 3. We know that 8 is 2 to the power 3 and 27 is 3 to the power 3. When you do that, we see it get cancelled out and you are getting 2 over 3. Try this one and see 40 Are we getting 40 as any number to the power 3? We are not getting. So what we can do here, you can find out what are the prime factors. So we'll take 40, divide and see what are the factors. You get 20, divide by 2, you get 10, divide by 2, you get 5. You get 2 to the power 3 and 5. So I'll write down, instead of 40, I'll write 2 to the power 3 times 5 to the power 1, 2/3. 135, how can I write? 135, I can divide by 5, 5 times 2, 10, 35, 5 times 30, 25, 5 times, yeah. So here, how can we find out what are the factors for 135? You can divide by 5, 5 times 2, 10. For 35, that's 7. Then I see you can divide by 3. 3 times 9, 3 times 3, and 3 times 1. So how many 3's are there? I can write instead of this as 3 to the power 3 times 5 to the power 1. I'll erase this. So here, this 1 to the power 1/3. Now I can take this power for all these numbers. So I can rewrite as 2 to the power 3 multiplied by 2/3. 5 to the power 1 multiplied by 2/3. Multiplied by. Here also consider 1/3 power for both numbers. 3 to the power 3 into 1/3. 5 to the power 1 into 1/3, you get 1/3. Now try to simplify. 3 get cancelled out. These 3 get cancelled out. You get 2 here. You get 3 here. How can we simplify these two numbers? Now we see you are multiplying same base with different powers. What's the law? That's the law number 1. When you are multiplying with the same base and different powers, you add the power. So what you get here, when you add 2/3 and 1/3, 2/3 plus 1/3, you get 3 3's. 3 over 3 becomes, you get 1. So finally you are getting, instead of these two, you get 5. So what's the answer? You get here, what's the mistake here? I forgot to put 2 to the power 2. So here 2 to the power 2 times 3 times 5. 2 to the power 2 is 4. 4 times 3, 12. 12 times 5, you get 60. So when you use laws of indices, you can find out answers. Now we'll look at review exercise in your textbook. Question number 1 says simplify and find the value. So here at once we can see what's the law here. Law number 1. When you get same base, different powers, you add the powers. So 2 plus 3 becomes 5. And you are asked to find out the value. So how can you find out the value? 2 times 2 times 2 times 2. 2 5 times, you know, that's equal to 32. What about this one? Which law? Third law. Power of a power. What you do? You multiplied the powers. So what you get here? 4 times 2, 8. So what is 2 8 times? 2 to the power 7 is 128. When you multiply by 2 again, you get 256. Now you get a negative power. How you convert to a positive power? By taking the reciprocal. We can take to the new denominator as a positive power. So what is 3 squared? You get 1 over 9. Now look at this one. You can apply two laws. First, to the numerator, this is multiplication. When you do multiplication, you add the powers. 3 plus 2 becomes 5. Now you can apply the division rule, second law. When you subtract, when you divide two indices, you have to subtract the power. So what happens here? 5 minus 5 becomes 0. Now again, the fourth law. Any number to the power 0, what's the answer? You get 1. Here also several laws. First, addition law. That means first one, when you have multiplication with different powers, you add the powers. 5 plus 2, 7. Now you can apply law number 2, subtract the powers when you get division. So 7 minus 6, you get 1. So what is 3 to the power 1? You get 3. Now look at this one. You get which law? Third law. Here, power of a power. How you do that? You multiply the powers. 2 times 2, 4. Divide by 5 to the power 3. Now use second law. Division becomes subtracting the powers. 4 minus 3 becomes 1. So 5 to the power 1 is 5. Look at this one. Several laws again. First, multiplication one. So what you do? You multiply the powers. 2 times 3 becomes 6. And then use multiplication law. That's law number 1. 6 plus 4 becomes 10. Now use second law. That's division. You subtract the powers. So what's the answer? 10 minus 8 becomes 2. So what is 2 to the power 2? You get 4. This one, again, first law. When you have multiplication, you add the powers. Minus 3 plus 2. So what is minus 3 plus 2? Minus 1. But we know 5 to the power 0 is 1. Now negative power. How can we convert to a positive power? By taking the reciprocal. So this goes to the denominator as 5 to the power 1. So the answer is 1 over 5. This one. Third law, multiplication. So first simplify this one. 2 times minus 2 becomes minus 4. And here nothing means you need to know that's power 1. Now you can use first law. Adding, when you multiply two numbers, you add the power. So here what you get? 5 to the power minus 4 plus 1. And we know 3 to the power 0 is 1. So what is minus 4 plus 1? You get 5 to the power minus 3. Again, you can convert to a positive number by taking this one down. 5 to the power 3. What is 5 to the power 3? 5 times 5 times 5. You get 125. Now, in question number 2, you are asked to simplify. Again, we have to use the laws of indices. Same base, different powers multiplication. You have to use law number 1. Add the powers. Without any power means you need to remember this is 1. Now, we'll add the powers. 2 plus 3, 6. 6 plus 1, you get 7. This one, a to the power 5, and without a number means 1. But we know a to the power 0 is 1. Now, add the powers. 5 and 1 becomes 6. This one, which law? Third law. Power of a power. What you do? Multiply the numbers. 3 times 2, you get 6. Here also, third law, multiplication. So 3 times 2, 6. Now again, law number 1. When you multiply, you have to add the powers. 6 plus 2, you get 8. Now look at this one. X, y, whole thing squared, you have to write separately. So this means you are squaring both numbers x and y. But we know x to the power 0 is 1. So what's the answer here? X squared, y squared. Now look at this one. Power 3 is outside. Now there are several terms inside brackets. So you have to consider power for all terms. So here when you are considering power for all, you have to write down 2 to the power 3 and x to the power what? You multiply these two. 3 times 2, you get 6. So what is 2 to the power 3? 2 times 2 times 2, you get 8x to the power 6. Now look at this question. How you do? You just simplify the numerator. I can just multiply 3 and 2 and write 6. How many p's are there? This is 1. Another 1 is there. According to law number 1, when you have multiplication, you add the powers. 1 and 1 becomes 2 and q is there. So when you are simplifying the numerator and the denominator, I can see 6 get cancelled out, p squared get cancelled out, and you get only q. What about this one? You can just multiply the numbers. 2 times 5, I can write 10. Here, x to the power 1 and x to the power minus 2 there. So that means you have to add the powers. Minus 2 plus 1, what you get? You get minus 1 and y remaining. But I can rewrite this as 10y and I can take x to the power minus 1 as a positive power by take it down. What about this part? First you can apply law number 3. Consider the power for all the numbers. 3 to the power minus 2, a to the power minus 2. Then try to simplify the numerator. What is numerator? I can do 3. Here, these powers I can rewrite as positive powers. So I can write 3 squared here, 4a squared b squared I can write as it is because all positive powers. These two I can take it down and write down 3 squared and a squared there. This one I can write as it is. Now try to simplify. This 2 and this 4, I get 2. 3 squared is 9. Now try to write down. I get 2 a squared b squared over 3 squared is 9. 9 a squared and ab. Now use first law to the denominator. I can rewrite as 2a squared b squared over 9 is there. How many a's are there? This is 1. 2 plus 1 becomes a to the power 3. So b only once. Now I can use second law. When you get division, you subtract the powers. 2 over 9 stays as it is. And here what happens? You subtract the powers. 2 minus 3 becomes minus 1 in the numerator. So I can take it down and write a in the denominator. This one 2 and here 1. 2 minus 1 becomes 1. So I can write b in the numerator. So what's the answer? 2b over 9a. Now we'll look at example 1 in your textbook. It says find the value of this one. So you have given radical forms and you are asked to find out the value. So what we can do? We can write as an index form and then think about how we can find out the answer. Here what is 3 means? Small 3 means cube root. I can write as an index notation as power 1 over 3. Now think about how can I write 27 in terms of any number to the power 3. I know 3 to the power 3 is 27 and here 1/3 is there, so you multiply the powers. 3 get cancelled out. 3 to the power 1 is 3. What about this one? 25 square root. How can I write 25 square root? As power half. And then I have minus 2 as well. So according to third law, you can multiply the power. So I get 25 half times minus 2. 2 get cancelled out. You get 25 to the power minus 1. How can I write as a positive number? I can take it down as 25 to the power 1. That means 1 over 25. Now look at the next one. I can write this one as improper fraction. So cube root is there. 8 times 3, 24. 24 plus 3, 27. So I can write 27 over 8 for the inside number. Then I can consider power 1/3. That's cube root. So 27 and 8 you have to take cube root. So 8 to the power 1/3. Now see how can you write down 27 as a power of 3. I know that 3 to the power 3 is 27. 2 to the power 3 is 8. Now consider powers by multiplying it together. You get 3 to the power 1 over 2 to the power 1. So what's the answer? You get 3 over 2. Now we'll look at example number 2 in your textbook. Simplify and express the answer with positive exponents or indices. Exponents is another word for indices. So here positive power. We'll try this one. What it means? Square root means power half. And this one power 3. So when you multiply the powers according to third law, what you get? 3 over 2. So that's a positive power. This one, what's inside? This is cube root. Cube root means 1/3 into minus half. Here according to third law, you can multiply the powers. So here you get minus 1 over 6. But this is negative power. You are asked to convert to positive powers. I can write 1 over a to the power 1 over 6. This one, first consider the power here in the denominator. This is square root. So square root means minus 3 over 2. Now convert to a positive power by taking it up. So this becomes positive 3 over 2. Now we'll look at the third example. So in the third example, you have given this one. So here what's the first thing we can do? We can consider power for both the numerator and the denominator. Then what's the next step? You need to write down 27 in terms of any number to the power 3, 64 also any number to the power 3. So what is 27? We know this is 3 to the power 3. What about 64? We know that's 4 to the power 3. So when you do multiplication, what happens? You get 3 squared in the numerator. That's 9. 4 squared, that's in the denominator. That's 16. Now look at the second one. You have to first consider the power, both the numerator and the denominator. Then think about what's the number to the power 4 equals to 16. What's the number? We know that's 2 to the power 4. What about 81? 81 is 3 to the power 4. Then when you multiply the powers, what happens? You get 2 to the power minus 3 and 3 to the power minus 3. Now you get negative powers. You can't find the answer. So you need to use the other law, how you convert to positive powers. You have to flip the terms. 2 to the power 3 goes to the denominator. 3 to the power 3 goes to the numerator. So what is 3 to the power 3? 3 times 3 times 3, you get 27. What is 2 to the power 3? You get 8. So what's the answer? 27 over 8. Now here in the textbook, you have given a complex number. So we'll try to do that. So here it says 125 or 65 to the power minus 1/3. So first thing you have to take this one power for both the numerator and the denominator. Now this one, how can I write? It's a radical form. Fifth root is given. I can write this one as 32 to the power 1/5 and then 3. But I know 3 to the power 0 is 1. Now try to simplify. I need 125 as a power of 5. As a power of any number to the power 3. So how can I write 125? I know that's 5 to the power 3. Then when you multiply, what happens? This 3 get cancelled out with this 3. What about 64? What's the number to the power 3 is 64? 4 to the power 3. When you multiply by 1/3, 3 get cancelled out. What about this one? I can write 32 as any number to the power 5. What's the number? We know this is 2 to the power 5. And this is 1. Now try to simplify. You get 5 to the power minus 1, 4 to the power minus 1. Here you get 5 get cancelled out. You get 2 to the power 3. So here negative powers you can flip and write down. I can write this one as 5 goes to the down and 4 goes up. And what is 2 to the power 3? 2 times 2 times 2, you get 8. So what's the answer? 32 over 5. Now we look at example number 4. So you have given radical form. Here 3 is there, means this is cube root. So first we'll write down 343x 3 over 2. What's the power? Cube root means 1/3. Now try to simplify. You have to then consider this one for both the numbers. So here you can write down 343 to the power 1/3 and x to the power 3 over 2 times 1/3 over x. Now we see this 3 get cancelled out. You get x to the power half. How can we write down 343 as any number to the power 3? So how can we find out this one? What's the number to the power 3 is 343. So try with 5. We know 5 to the power 3 is 125. 25. 6 to the power 3, you are not getting 3 as the final digit. 7 to the power 3, 7 times 7, 49. 49 times 3, 49 times 7, you get 343. So you can write instead of 343 as 7 to the power 3, then you multiply by 1/3. Then here you get x to the power half and x here. So 3 get cancelled out, you get 7 in the numerator. What happens here? You can simplify x terms. This is 1 as the power half minus 1. According to law number 2, you can subtract the powers. Half minus 1 becomes minus half. But you can't keep the answer like this, so you have to keep as a positive power. I can write as x to the power half, or I can write square root x, because square root x means x to the power half. Now we'll look at exercise 2.1 in your textbook. It says express the following using the radical symbol. So you're asked to write down the radical symbol. Okay, 1/3. What's 1/3 means? Cube root. So we can write P and this symbol, a small 3 there, that represent cube root of that. This one, we can first take a squared and then consider power 1/3. So here, how can we write as radical form? I can write a squared with cube root. This one, I can write x to the power minus 2 with 1/3. Then I can write x to the power minus 2 here, cube root of that. What about this one? I can rewrite as m to the power 4 with 1/5. That means fifth root. So m to the power 4 fifth root. What about this one? I can write y to the power minus 3 and 1/4 power. So what is 1/4? Fourth root. So I can write y to the power minus 3 inside and 4 outside the square root symbol. This one I can rewrite as minus 5 with 1/3 power. So what is 1/3? Cube root of x to the power minus 5. Now look at second question. Write using positive exponents or indices. So here negative power is given. So we'll try to do, this symbol means square root. So square root means you can take power 2, power half. නෑ ඒක අහලා නෑනේ. රැඩිකල් සිම්බල් එකනේ. පොසිටිව් පවර් විදිහට අහලා නෑ. ඕනනම් ඉතින් කරන්න. ඕනේ නෑනේ. මොකෝ රැඩිකල් ෆෝම් නේ. නෑ මේකෙත් එහෙනම් කමන්නද මෙතන පණ? Now we'll look at question number 2. Write using positive exponents or indices. So you're asked to write in positive exponents. So here nothing means what's the root value? Square root. Square root means power half. So here this is m to the power minus half. Can you keep that answer like that? No, because they ask positive exponents. So how you do that? You flip this one to denominator and write down as a positive power. This one, 3 is there. That means you have to consider cube root. This is negative power. How can we convert to positive power? By taking it to the denominator. This one, 5 is there. So that means fifth root. You get minus 2 over 5. How can you write as a positive power? We take it down and write down power 2 over 5. This one, square root is there. So square root means power half. And then you get minus 3. So when you use laws number 3, you multiply the powers. You get minus 3 over 2. When you want to convert to a positive power, we take the reciprocal. So here this goes down and write 3 over 2. This one, negative power is there. But here fourth root. What is fourth root means? You divide by 4. So here this is a negative power. Convert to a positive power by taking upside down. So you get 3/4. What about this one? 3 is there. That means cube root. You are getting cube root of that with power minus 5. Then you multiply the powers. You get minus 5 over 3. Convert to a positive power by taking the reciprocal. This becomes 5 over 3. Now look at this one. This one is square root symbol. So square root means power half. So first thing we can write this one as minus 3 over 2. Now you have to convert to a positive number. So we can take it to the numerator. So this becomes power 3 over 2. This one, this is cube root. Cube root means you can consider the power as 1 over 3. Now this is a negative power. Convert to positive by taking up. This becomes positive 2 over 3. This one, 2 is just outside. So you have to write as it is. Then think about the radical form. 3 means cube root. Then you can write this one as minus 2 over 3. But we can't keep this as a negative power. You keep 2 as it is, only we are taking this one. So x goes down as 2/3. What about this one? Here also there's a big 3. It means just 3 outside, not as cube root of this. So here what you do, you keep 1 over 3 there as it is, and this means square root. How can you write square root? Minus 5 over 2. So when you simplify this one, 1 over 3, you have to write as it is, only this one goes up. So when you write in the numerator, you get 5 over 2. You can rewrite this one as a 5 over 2 as the power, divide by 3. Now we'll look at the third question. You are asked to find the value. So again, radical forms given. So we'll first write these in index notation. So square root of 25. Square root means we know power half. So then think about what is 25 as a square term. 5 square. So square and this power half get cancelled out. Square root of 25, you get 5. This one, fourth root given. So 16, 1/4. 16, what's the number to the power 4? 2 to the power 4. Multiply by 4, you get 2. What about this one? Square root, that means power half. And then multiply by 5. So what's the answer? You first multiply 4 to the power 5 over 2. So what's the square number to get 4? 2 to the power 2. 2 to the power into 5 over 2 becomes 2 to the power 5. So what is 2 to the power 5? 32. Now look at this one. Cube root is there. So how can I write inside number? 27 1/3 and then multiply by 2. I get 27 to the power 2/3. What's the number to the power 3 to get 27? We know that's 3 to the power 3. When you multiply, these 3 get cancelled out. What is 3 squared? 3 squared is 9. This one, this is 4th root. I can write 81 3 over 4 because this is 4th root. How can I write a number to the power 4 as 81? I know that's 3 to the power 4. When you simplify, you get 3 to the power 3. What is 3 to the power 3? You get 27. This one, you get cube root. Cube root means 1000 squared. You have to divide by 3, 1/3 as the power. Then what is 1000 means? This is, here I put an extra 0. This is 3 zeros. So here, how can I write 1000 as any number to the power 3? This is 10 to the power 3. That means you multiply the powers, you get 10 squared is 100. Now take this one. You have to consider power for both the numerator and the denominator. So first step is that. Now try to simplify. 27 write as any number to the power 3. We know that's 3 to the power 3. What about 125? What's the number? 125 is 5 to the power 3. Now simplify. 3 get cancelled out. 3 squared. You get 9. 5 to the power 2. You get 25. Now look at this one. 81. So first thing, consider power for both the numerator and the denominator. And then think about the denominator is 4. That means any number to the power 4 should be equal to 81. So that's 3 to the power 4. What about this one? 10,000. That's 10 to the power 4. When you simplify, what you get? 3 to the power 3 is 27. 10 to the power 3. You get 1000. So the answer is 27 over 1000. Now look at this one. It's 1 to the power minus 5 over 6 and 64 to the power minus 5 over 6. But we know 1 to the power any number is 1. So here we can write any number. Here is 1. Then you have to write down any number to the power 6 is 64. What's that? 2 to the power 6. So I can write down this one as 64 as 2 to the power 6. And then I get minus 5 over 6. 6 get cancelled out. So what's remaining? 1 over 2 to the power minus 1. We can't find the answer. We have to convert to positive powers. So take the reciprocal. That means this one goes up. What is 2 to the power 5? You get 32. Now look at this one. Try to simplify. Here 27. Consider power for both. I'm considering power for both. Then what's the next step? Consider here this one is 3. So you need to find any number to the power 3 is equal to 27 as well as 64. So how can I write? I can write 3 to the power 3. This one 64 I can write 4 to the power 3. Now simplify. So what's the answer? 3 to the power minus 2 and 4 to the power minus 2. I can't find the answer when you get negative powers. So I have to switch it to positive powers. So I need to take the reciprocal. 3 to the power 2 goes there, 4 to the power 2 goes up. So what's the answer? 4 squared, you get 16. 3 squared, you get 9. So answer is 16 over 9. Now look at this one. This is a decimal value. When we deal with fractions, it's easier than dealing with decimals. So I want to convert 0.81 to a fraction. So how can I write 0.81 to a fraction? I can write 81 over 100. Then consider power for both the numerator and the denominator. 81 to the power 3 over 2, 100 to the power 3 over 2. Now think about what's the square term. 81 is 9 squared. What's 100? That's 10 squared. Now we see these two get cancelled out. What is 9 to the power 3? 9 times 9, 81. 81 times 9. You get 729. So the answer is 729 over 10 to the power 3 is 1000. So you get 729 over 1000. What about the other one? How can we convert to a fraction? 0.125. I can write 125 over 123,000. Then consider power negative 2 over 3 for both numerator and the denominator. Now 125. What's the power of any number becomes 125? 5 to the power 3. What's this one? 1000. We know that's 10 to the power 3. 3 get cancelled out. So 5 to the power minus 2 over 10 to the power minus 2. You have to flip it to get the positive power. So 5 to the power 2 goes to the denominator. 10 to the power 2 goes to the numerator. So what is 10 squared? You get 100. What is 5 squared? You get 25. Now you can simplify. How many 25s for 100? We know that's equal to 4. Now look at this part. So you have given again fractional powers. So here first thing consider power for both numerator and the denominator. Here also consider the power both the numerator and the denominator. And we know 2 to the power 0 is 1. Now try to write down this one as a square term. 4, you can write 2 to the power 2. 25, you can write 5 to the power 2. 3 and 4, negative powers, you can flip it and write 3 over there, 4 over there, because negative powers you can convert to positive powers. Now, you can simplify and write 2 times 4, you get 8. 5 times 3, you get 15. This one. Power එක පේන්නේ නැහැ. Power එක පේන්නේ නැහැ. නිකන් කියන්න මම කියන්න. 3. Okay. So in this question, here This is power 3, power 3. So here, look at this one. Again, consider the power for both the numerator and the denominator. This one, I can take both to numerator and the denominator. Now think about how we can write these two, all these numbers as a square number. 9 we know, 3 squared. 100 we know, that's 10 squared. 4 is 2 squared. And 25 is 5 squared. Now we see all these get cancelled out. What's remaining? You are getting 3 to the power minus 3, 2 to the power 3, 10 to the power minus 3 and 5 to the power 3. Negative powers you can switch. I'll switch these two. 10 to the power 3 goes to the numerator, 3 to the power 3 goes to the denominator. And 2 to the power 3 is 8, 5 to the power 3 is 125. Now try to simplify. 10 to the power 3 is 1000. 3 to the power 3, you get 27. Now, we'll try to simplify this. We know when you divide by 25, you get 25 times 5 is 125. 25 times 40, you get 1000. Now, can you simplify further? 5 times 1, 5 times 8. And here, you can't simplify further. So what's the answer? 6 times 6 is 64. 27 times 1 is 27. Now we'll look at the third one. You get a mixed power. So it's easier to convert to an improper fraction. So here first thing we can do 1 and 1/3. How can I write? 3 times 1, 3. 3 plus 1, 4. I can write as 4 over 3. This one, 81 there. Convert to improper fraction. 4 times 1 is 4. 4 plus 1, 5. So this is minus 5 over 4. Now consider first number as a number to the power 3. Second one as a number to the power 4. Because denominators are 3 and 4. I can write 27 as 3 to the power 3. 81 as, what's the number? 3 to the power 4. So when I simplify this, what am I getting? 3 to the power 4. What is 3 to the power 4? First we'll write it. And you get 3 to the power minus 5. Now according to first law, multiplication, you add the powers. So here 4 minus 5, you get minus 1. You can't keep the answer like this. You have to convert to positive powers. So you get 1 over 3. Now look at this part. Again you got mixed numbers. So convert to improper fractions. 11 times 9, 99. 99 plus 1, 100. I can write 100 over 9. What about this one? 4 times 6, 24. 24 plus 1, 25 over 4. Now, consider power for both the numbers. 100 to the power minus half. 9 to the power minus half. 25 to the power minus 3 over 2. 4 to the power minus 3 over 2. Now, what can I do? I know all these you have to use square terms because all denominator values are 2's. So, I can write 100 as 10 squared. 9 as 3 squared. 25 as 5 squared. 4 as 2 squared. Now, try to simplify. All these terms get cancelled out. you get 10 to the power minus 1, 5 to the power minus 3, 3 to the power minus 1, 2 to the power minus 3, all negative powers. So you need to switch places. These 2 goes to the denominator and these 2 goes to the numerator. So what am I getting? 3 to the power 1 is 3, 2 to the power 3 is 8, 10 and 5 to the power 3. 5 times 5, 25. 25 times 5 is 125. Now see whether I can simplify. I can simplify this with divide by this by 2. 2 times 4, 2 times 5. So what's the answer? I am getting 3 times 4, you get 12. 5 times 125. So what is 5 times 125? 5 times 5, 25. 5 times 2, 10. 10 plus 2, 12. 5 times 1 is 5 plus 1, 6. 625. Now we'll look at the second one. Decimals are given. Convert to fractions. So I can write this one as 125 over 1000. What about this one? I can write 25 over 100. Then if I want, I can simplify also. I'll simplify this one. 25 times 5. 25 times 40. When you simplify this, I get 8. What about this one? 25 times 1, 25 times 4. So I can write this one as 1 over 8 to the power 1/3 minus 1/3 and 1 over 4 to the power 3 over 2. Now what can I do? I need to consider power for both. 1 to the power any number is 1. 8 to the power minus 1/3. 1 to the power any number is 1. 4 to the power 3 over 2. Now consider this number as power of 3, this one as power of 2. So what's that? 2 to the power 3 is 8. 2 to the power 2 is 4. Now when you simplify, what you get? You get 1, 2 to the power minus 1 and 2 to the power 3. So what's the answer? When you add the powers, what you get? I get 1 over 3 minus 1 becomes 2 to the power 2. 2 to the power 2 is 4. So you get 1 over 4. Now look at this one. You get radical form. So how can I write this one? 3 is outside means cube root. I can write as 1/3. Square term is there. 4 is there outside, that means 4th root. I can write 3 over 4. Now when you multiply, I get 8 2/3, 16 3/4. Now try to write down 8 as a power of 3, 16 as power of 4. 8 I can write 2 to the power 3. 16 I can write 2 to the power 4. Now simplify. I get 2 to the power 2 multiplied by 2 to the power 3. Here, according to first law, I can add the powers. 2 plus 3, I get 5. So what is 2 to the power 5? You get 32. Now we'll look at question number 4. It says simplify and express using positive indices. So here we'll try to do those. Radical forms are there. 3 means cube root. So here we can write a to the power minus 1/3. Divide by a to the power here 3 means that's 1/3. Now division means you subtract the powers. So according to law number 2, you can subtract the powers. Minus 1/3 minus 1/3. So what you get here? You get minus 1/3 becomes minus 2/3. So you are asked to write as a positive power. So how can I write this? 1 over a 2 over 3. What about this one? B. Here again radical form. This is 5 there means fifth root. So you have to take minus 3 over 5. Divide by a 7 over 5 because fifth roots are given. Then what you do according to rule number 2? You subtract the powers. So a minus 3 over 5 minus 7 over 5. So what you get? Minus 3 minus 7 minus 10. So you get minus 10 over 5. When you simplify this, you get minus 2. But you need to write as a positive power. So how can I write? I can write as 1 over a squared. What about this one? Again, radical form is given. 3 means 1/3 we have to take as power, cube root. Divide by, here also 1/3. When you simplify, again apply second law. When you divide, you subtract the powers. What you get? A 2/3 minus 3 over 3. What's the answer? 2 minus 3 becomes minus 1 over 3. Write as a positive power, you get 1/3 down. So this is the answer for fourth question. Now look at this one. Again, radical form is there. 3 means cube root. So first we'll take cube root and then consider power half. What about this one? 6 is there. That means sixth root. You have to consider minus 5 over 6. What's the next step? Here, according to law number 3, you have to multiply the powers. X, you get 5 over 6 multiplied by minus 5 over 6. Now, law number 1. When you get multiplication, you add the power. So, what is 5 over 6 plus negative 5 over 6? You get 0. So, what is x to the power 0? Any number to the power 0 is 1. Look at this one. You get square root. First consider square root. It becomes 3 over 2. Then you have negative 2 and then another minus half means you multiply those two together. What happens here? 2 get cancelled out. So you get a 3 over 2 minus 1 into minus 1. You get positive 1. Now, when you simplify, you get 3 over 2. Look at the other one. Square root symbol. Square root symbol means power half. So you get x squared, y squared, power half. And then you get minus 6 outside. So what happens there? You can multiply. You get 3 here, then x squared, y squared with negative 3 outside. So negative 3 means you multiply both these by minus 3. X you get 2 times minus 3, minus 6. Y also you get minus 6. But you have to keep as positive powers. So we take 1 over x to the power 6 and y to the power 6 to the denominator. Now look at the next part. It says square root of 4a minus 2 as the power and 9x squared. So here first thing you have to take square root. So square root means you have to take both first as power half. That's the first step, because square root is power half. Now consider for both, or for all these numbers power 2 you have to consider. 4 to the power half, a to the power minus 2 times half, 9 to the power half, and x squared multiplied by half. Now try to simplify. These two get cancelled out. These two get cancelled out. So what is 4 square root? So 4 square root is, that means I can write 2 or 2 to the power 2, and then 2 get cancelled out. I can write 2. Then here what I get? Minus 1 as the power. What about this one? I get square root of 9 is 3. And what is here? You get x. Now we can't keep the answer like this, so you have to rewrite it. 2, okay, it's there. 3x also there. A to the power minus 1, I have to take it down. So I can write 3xa when I take a to the power minus 1 down. Now look at this one. Cube root is there. Cube root means you have to take power 1/3 for this one. So power 1/3, and here you get minus 2. So what you get? I can simplify this part to 27 x to the power 3. When you multiply these two, I am getting minus 2 over 3. Now consider the power for both of these numbers. So I can write 27 to the power minus 2/3 and x to the power 3 times minus 2/3. Now I can simplify and write 27 to the power minus 2/3 and x to the power minus 2. Now 27, how can I write as a power of a number? The denominator is 3. That means I have to write as power of 3. I know this is 3 to the power 3. So I can simplify this. 3 to the power minus 2 and x to the power minus 2. So I have to convert to positive powers. So what I can do, I can take it to the denominator and write 3 squared and x squared. So what is 3 squared? 9. I can write 9x squared as the answer. We'll take this one again. You have minus 2 as the power. First we'll consider this one. So I can rewrite this as, this one is square root of x to the power 5. I can write x to the power 5 over 2. Then what's the next step? Consider the power for all of these terms. I can take x to the power minus 2. This one with this one, when you multiply, I get positive 2. What about this one? 5 over 2 multiplied by negative 2. So when you do the simplification, I get this one. What happens here? I get x to the power minus 5. Now try to convert to positive power. So what I get? I get this one. I can put it down as positive power. So here x to the power minus 2, I can write x squared. Then x to the power minus 5, I can write as x to the power 5. Now what happens? X to the power 5 and x to the power 2, I can simplify. So this is law number 2. Division becomes subtraction. So you can do y squared 5 minus 2. So what you get? 5 minus 2 is 3. So you get y squared and x to the power 3. Now we'll look at how we can solve equations. So far we discussed about how you can apply laws of indices. Now we'll see when you get two equations something like this, x to the power m is equal to x to the power n. So this is an equation in index notation, and if x is not equal to 0, what can we say? So here, if bases are equal in an equation, you can say these powers are equal. M is equal to n. And also, if there's an equation x with power m, and if this one is with power m. So here, same indices and different bases. If these two are equal, what can we say? We can say x is equal to y. Here also we have to take m is not equal to 0. When m is not equal to 0, if you get something like this, you can straight away equate the bases. So here, there's a mistake. Equate the bases. Here what we do, same bases are given. If the two sides are equal, you can equate the powers. So here, these are the two properties in equations. So here, remember those two properties you can apply when you get equations in index notations. We can use those two. Now we'll see how we can solve equations. Okay, so we'll take the first one is given 2 to the power x. So according to the first property, if we can write down 32 in the same base as on the other side, we can easily solve this. So here first step is you are finding 32 in terms of 2. What's the number? 2 to the power 5 is 32. Then according to the first property, bases are equal. Then what can you say? You can say powers also equal. So x equals 5. Now we'll take the next one. 3 to the power x is 81. Now what's the base? Base is 3. So that means we have to write 81 in terms of power 3. So how can we write? I can write 81 as 3 to the power 4. Now we see both bases are equal. That means we can equate the powers. So x equals 4. This one, equation is given. One side is base 2. Can we write 8 in terms of power 2? What's the answer? 2 to the power 3. So if the bases are equal, I can write the powers also equal. Then how can we find x? I can take minus 1 to the other side. X becomes 3 plus 1 is equal to 4. This one, 9 is the base and other side 27. Can we write down 27 in base 9? You can't write down. So then we have to think about another base. So how can I write 9 and 27? What's the common base? I can write as 3 as the base. So 9 I can write 3 squared 27 I can write 3 to the power 3. So here, according to law number 3, power of a power. So you can multiply. So here what you get 3, you have to multiply both these numbers by 2. You get 2x minus 2 is equal to 3 to the power 3. Then what can we say? Bases are equal. I can equate the powers. So what's the answer? I can take this 2 to the other side. You get 5. So what's the x value? X value is 5 over 2. Now we'll look at this question. Now we see we get 3 terms. Earlier we had 2 terms. Now we'll use index laws to solve this one. Here, can you remember the first law? When you get multiplication, you add the powers. Already addition is given. I'm doing the reverse process. I can rewrite this one as 9 to the power x into 9 to the power 2. And then I see when you look at these two, 9 to the power x is common. Take it out. So what's remaining? 9 squared minus 1 is equal to 720. So how can I find 9 to the power x? I can divide this by this number. 9 squared is 81. 81 minus 1, 80. So I can divide by 80. 0, 0 can get cancelled out. 8 times 9 is 72. So I get 9 to the power x is 9. So what's the power there? I can see this is power 1. Same base. That means you can equate the power. So what's the answer? X equals 1. Now look at this one. So here again you get 3 terms. Try to split this one using the first law. X plus 3 I can write x and power 3. Then what I can do, I can see 5 to the power x is common. Take it out. You get 5 to the power 3 plus 1. So what's the answer? So what is 5 to the power 3? What is 5 to the power x? That's equal to 630 divided by 5 to the power 3 is 5 times 5, 25. 25 times 5, 125 plus 1, 126. So when you multiply by 5, what happens? 5 times 6, 30, 3 remaining. 5 times 2, 10 plus 3, 13. And you get 1. So you get 126 times 5 is 630. So here 5 to the power x is equal to 5. 5 is, we can write power 1. So here when the bases are equal, you can write the powers also equal. So you can write x equals 1. Now look at this question. You get 5 times 25 to the power 2x minus 1 equals 125. So first thing, you can get rid of this 5. So I can divide both sides by 5. So what happens? This 5 get cancelled out. I get 25 to the power 2x minus 1 is equal to 125 divided by 5. You get 2 here. 5 times 2, 10. 2 remaining, 5 times 5. So here I can write this one as 25 to the power 1. Same base is there. This is an equation. So I can write 2x minus 1 is equal to 1. So what can I do? I can take minus 1 to the other side and write 2x equals 1 plus 1 becomes 2. So what is x? 2 divided by 2, I get 1. Now we look at this question. Here you have given an equation and you are asked to find out the value of a. So here what we can do, we can try to write down, now the power is x now, we'll try to make the same power on the other side. So I can write 3 squared and x out. What about this one? This is multiplication, 2 to the power 3 and x out. Now what is this one? I can write this one as 9 to the power x and 2 to the power 3 is 8 to the power x, is 8 to the power x. Now I can see power x is the same. So I can write instead of this 9 times 8 to the power x. So same thing, considering power x for both, 9 to the power x into 8 to the power x. Now what can I say? You get different bases but the power is the same. So what's the second property we learned? When you get same powers, you can equate the bases. So 9 times 8. So what's the answer? A equals 72. Now we'll look at example 1 in your textbook and you're asked to solve these equations. So think about the two properties. When the bases are equal, you can equate the powers. When the powers are equal, you can equate the bases. So here we get this one, 64. Try to write in terms of 4. What's that? 4 to the power 3. So how can we write? We can straight away write x should be equal to 3. This one, x to the power 3. If we can write down the same base, same power, we can find out x. So what is 343? Can you remember we did this before? 7 to the power 3 is 343. So that means same powers, you can equate the bases. This one, you get 3 terms. How can we write down this? So first thing, we can convert to the same base. 9 and 27. What's the common base? We know that common base is 3. We can write 3 squared. What's 27? I can write 3 to the power 3. Now we know here 3 means 3 to the power 1. Now according to law number 1, we can multiply. So here we can first simplify this. What you get? 3 to the power 1 into 3 to the power 2 times 2x is 4x. 2 times minus 1 is minus 2. Then what you get here? 3 to the power 3 times minus x, you get minus 3x. Then according to law number 1, we know that when you multiply with the same base with different powers, you can add the powers. So we can use that. 1 plus 4x minus 2 equals 3 to the power minus 3x. Then simplify. You get 3 to the power. 1 minus 2 is minus 1. So you get 4x minus 1 equals 3 to the power minus 3x. Now what we can do? Same base, different powers, you can equate the powers. I can write 4x minus 1 is equal to minus 3x. When you take minus 3x to the other side, I get 7x equals, I'm taking minus 1 to the other side. 7x equals 1. So what's the answer? X equals 1 over 7. Now look at exercise 2.2 in your textbook. The first question says solve each of the following equations. Again, look at carefully whether you can write as the same base or same power. Here we can write down 9 as 3 squared. Same bases are there, so you can equate the powers. So the answer is x equals 2. What about this one? Can we write 243 in terms of power 3? What's that? 3 to the power 5. 3 to the power 5 is 243. Now same bases are there. You can equate the powers. X becomes, when you take 2 to the other side, 5 minus 2, you get 3. What about 32? Can you write as power of 4? You can't. So that means you have to find out the common base. So 4 and 32, what's the common base? You have to write in terms of 2. 4 I can write 2 to the power 2. 32 I can write 2 to the power 5. So here when I multiply these two, I get 2 to the power 6x equals 2 to the power 5. Now I can equate the powers because bases are equal. So I can write 6x equals 5. So what's x value? 5 over 6. Now we'll take the next part. 2 and 8. We can convert to base 2. I can write 8 as 2 to the power 3. So this becomes 3x. Then same bases are there. I can equate. So when I do that, I can take 3x to this side. 5x minus 3x becomes, when I take minus 2 to the other side, you get 2. So 2x equals 2. So how can I find x? I divide by both sides by 2. So I get x equals 1. What about 8 and 4? What's the common base? Common base is 2. I can write 8 as 2 to the power 3. What about 4? I can write as 2 to the power 2. Then when I expand brackets, I get 2 to the power 3x minus 3. What about this one? I get 2 to the power 2x. So when I look at these two, same bases, I can equate the powers. Take 2x to this side. 3x minus 2x is equal to 3. When I take minus 3 to the other side, you get 3. So 3x minus 2x is x. X equals 3. Now look at this one. X to the power 3 is 216. So how can I write this number as power 3? What's the number? 6 times 6, 36. 36 times 6, 260. That means I can write this one as power 6 to the power 3. Now in this case, powers are equal and you can equate the bases. So here powers are equal. I can equate the bases. So you get x equals 6. Now look at this question. You get a radical form. Here big 2 means 2 outside. First thing, we have to get rid of this number 2. I can divide both sides by 2. What happens? I get square root of x is equal to 3. 6 divided by 2, 3. So here, what is this means? X to the power half. Square root means x to the power half is equal to 3. So what I can do to get rid of this power half? I can square both sides. When I square both sides, what happens? Straight away I get the x value. X is equal to 3 squared. I get 9. Now look at the next one. Small 3 is there. That means cube root. So I can rewrite this equation 2x squared and power 1/3 is equal to, now you get power 1/3. How can I get rid of power 1/3? I want to take both sides power 3. So I am taking power 3 both sides because I want to get rid of this 1/3. So what happens now? So you get 3 get cancelled out. You get 2x squared is equal to 2 to the power 3. You get 8. Now divide both sides by 2. You get x squared. X squared is equal to 4. So what's the square root value for 4? We can write x can be plus or minus 2. Now we'll look at question number 2. It says solve each of the following equations. So you have given an equation. So what's the first step? If you can write as the same base, you can solve. 2, 8, 256. We can convert everything to base 2. 8 you can write 2 to the power 3. 256. We know 2 to the power 7 is 128. 128 multiplied by 2 again, you get 256. So 2 to the power 8. Now use law number 1. Multiplication, we add the powers. 3x and x becomes 4x. Now you get same base. You can equate the powers. So 4x equals 8. So what's the x value? 8 divided by 4, you get 2. Now look at this one. 8, 2, 4. What's the common base? Again, you can convert everything to power of 2. 8 you can write 2 to the power 3. This one you can write as it is. 4 we can write 2 to the power 2. Now expand brackets. You get 2 to the power 2x and this you get 2x minus 4. What about this side? Multiplication, you can add the powers. 3 plus x minus 1. So what's the answer? You get 2, 3 minus 1 plus 2, you get x plus 2. So what about this one? You get 2x minus 4. So same base, different powers. So what you get? I can write x plus 2 is equal to 2x minus 4. I can take x term to the other side. 2x minus x. I get x. Minus 4, I can take it to the other side. Minus 4 plus 2, I get 6. So what's the answer? X equals 6. Now we'll look at this question. 5, 25, 125. What's the easiest way to do? We can convert everything to base 5. So here 5 to the power 1. 25, I can write 5 to the power 2. 125, 5 to the power 3. Now simplify this one first. 1, 2 times 2, 4x. 2 times minus 1, minus 2. Now law number 1. Multiplication, I can add the powers. Now you can equate. First we'll simplify this. 1 minus 2 minus 1. So I get 4x minus 1. Same base, different powers, you can equate the power. So I get 4x minus 1 is equal to 3. 4x equals, take minus 1 to the other side. 3 plus 1 becomes 4. When you divide both sides by 4, what you get? You get x equals 1. Now look at the next question. 3, 9, 27. What's the common base for all of these three numbers? Base is 3. So I can rewrite 9 as 3 squared. What about 27? I can write as power 3. Now expand brackets. I get 2 times 3x is 6x, 2 times minus 2 is minus 4. What about the other side? 3 times minus 3x is minus 9x. Now, according to first law, I can add the powers. I can write 2x plus 6x minus 4 is equal to 3 to the power 9x. When you simplify this side, I get 6x and 2x becomes 8x minus 4 is 3 to the power minus 9x. Same base, you can equate the powers. So 8x minus 4 is equal to minus 9x. Take minus 9x to the other side. 8 plus 9. 17. X is equal to 4. So what's the x value? You get 4 over 17. Now look at this one. You get fractions now, but you can easily do these using the laws of indices. Now here, I can write 64 as 4 to the power 3. Now. So I can write the denominator as 4 to the power 3. But according to the law, I can, if I want to take this one to the numerator, I take the opposite power, opposite sign for the power. So I can write 4 to the power x. This one I can write in the numerator as negative power 3. Now again, bases are equal. You can equate the powers. So you get x equals minus 3. Now look at the other one. 3 and 27. So what's the common base? I can convert to base 3. First, I can multiply these two. According to law number 3, powers of power. So here I can write x times minus half as minus half x or minus x over 2. This one, how can I write? I can write 3 to the power 3. Then I can take it up and write 3 to the power minus 3. This is equal to minus x over 2. Now again, same basis, so you can equate the powers. So I can write this one is equal to this. Minus minus get cancelled out. X over 2 equals 3. X is equal to 2 times 3. You get 6. Now look at this question. 399. So again, we'll convert to the same base. I can write 9 as base 3, 3 square. Again, 3 as base 3 square. Now try to simplify. I get 3 to the power 4x divided by 3 to the power 2 is equal to 3 to the power 2x. Now, this is law number 2. Division, you subtract the power. So, how can I write? I can write this one as 4x minus 2. Same basis, you can equate the powers. So, I can write this one as, when you take 2x to this side, 4x minus 2x is 2x. When you take minus 2 to the other side, you get 2. When you divide both sides by 2, I get x equals 1. Now look at this one. I need to find out x and 1 over 8 is given. So here if I can write down 8 in terms of any number to the power 3, I can get rid of this denominator. So what is the number? I can write this one as 2 to the power 3. Then what's the next step? X squared is, consider power for all the numbers inside the brackets. 1 to the power any number is 1. When you take this one, you multiply by minus 2/3. Here 1, 3 get cancelled out. You get x squared is equal to 1 over 2 to the power minus 2. How can we write this one in the numerator? You take the positive power. When you look at these two, powers are the same. So if powers are the same, you can equate the bases. So x becomes 2. Now look at this one. You have given find the value using laws of indices. So here bases, different bases are given, 5, 6, 5, 3, 2. Now we'll try to convert to common bases. Here 3, 2 there, so if I can write 6 as base 2 and 3, I think I can simplify. We'll do first number I can write as it is. 6 I can write 2 times 3. That means 2 to the power 1. I can write 2 times 3 and I get 5. 5 to the power a plus 1. What about the denominator? I see 5 to the power a is common. I'll take it out. So the remaining part, 3 squared minus 2 squared. Now look at the numerator. 5a plus 3. I can write that number as 5a and 5 to the power 3. What about the other one? I am writing 2 times 3 also. This one I can write 5a plus 1, a and 5, 1. 5a is there. 3 squared is 9. 9 minus 4. You get 5. Now, in the numerator, I see 5 to the power a is common. I'll take 5 to the power a out. Then what's remaining? I get 5 to the power 3. 5 to the power 3 is 125. Here, what you get when I subtract this number, 5 to the power a, you get 2 times 3 times 5. So what is 2 times 3? 6. 6 times 5? 30. Now in the denominator, I get 5 to the power a and 5. Can you see? These two terms get cancelled out. So what's the final answer? 125 subtract 30. What you get? 95. So 95 in the numerator and 5 is in the denominator. When you simplify, you get 5 times 1, 5. 4 remaining, 5 times 9, 45. So what's the answer for this expression? 19. Now we'll see what are logarithms. So we did indices. Now we'll see what's the relationship between indices and logarithms. We'll take this one. We know 2 to the power 5 is 32. No? This is in index notation. So here we call this as base and this is the index and this is the value. Now I want to rewrite this in another form. We call that's the logarithmic form. Now we'll see what happens when you convert this index notation to logarithmic notation. So here we use LOG. LOG for logarithms. But in your textbook, we use another one, LG. I'll explain that one later. So here, what happens when you get base index? When you convert to log notation, the base, this one, we write here, slightly down to LOG term. So that is the base here. And what happens to this one? This value goes inside the logarithm and this becomes the index. So here, that's how you write down logarithmic notation. Now here, this is the index. So the index is equal to the logarithmic value. So this is the base, always base goes here and this is the value. So if you can remember this format, you can convert easily any index notation to logarithmic notation. Again, we'll take another one. 10 squared. We know that's 100. 10 times 10. How can I write this in logarithmic notation? I can write LOG. This is the base. Base goes here. And this value goes inside the logarithmic notation and the index goes there. So log 10 base 100 is equal to 2. Now in your textbook, there's a term called LG. So LG is another term for log 10 base. So you can remember, it's a short way of writing. If it's 10 base only, we can use LG. If it's another base, you have to write LOG with another base. So what happens to this one? Index is the logarithmic value. So remember that, how to convert index notation to logarithmic notation. We'll take several examples and see. So you are asked to write down these in logarithmic notation. So we'll take 25. So what is 25? We know this is 5 squared. How can we write this one in logarithmic notation? I can write LOG. This is the base. Base goes here. And the value goes inside the logarithm value and here power or index goes there. Again, 49 is 7 squared, 7 times 7. So how can we write down the logarithmic notation? Log base goes here. Then the value inside logarithmic expression. And what's the answer? You get 2. This one, how can I write in logarithmic notation? I can write LOG. What's the base now? Base is this number. Base goes here. Then the value is here and this becomes the index. You can write M. Now try to write down this one. How can I write in log notation? I can write LOG. This is the base. So base goes there and the index goes here and the value goes inside the log notation. So here, when you look at carefully, there's an easy way to find out the conversion. Here, can you see base and here? Think about this one, these two. What happens? 5 squared is equal to 25. Here, when you take base to the power this one, you get 25. What about this one? 7 squared, you get 49. a to the power m, you get x. A to the power n, you get y. So look at carefully, we can convert any index notation to logarithmic notation. And both ways, if you have given a logarithmic notation, you can easily convert to index notation. Now we'll look at a rule in logarithmic notation. So we'll take this one, x is equal to a to the power n. And we'll take y as a to the power m. Okay, same basis. I'm taking same basis. So how can I write this one in logarithmic notation? I can write this one as log. What's the base? Base a, and x becomes n. What about this one? I want to write this one as log notation. Log base a y is equal to m. Now, if this is equation 1 and this is equation 2, I want to multiply these two. This side, I want to multiply 1 and 2. What I am getting? X and y becomes xy. What about here? I am getting a to the power n times a to the power m. When you use law number 1 in indices, I get xy equals a to the power m plus n, because multiplication you add the powers. Then if I want to write down this index notation in logarithmic one, how can I write? What's the base? You get log, base is a. And what's the number? You get xy as the value. That should be equal to m plus n. Now what is m? According to this one, m is, I can write it again, log a xy equals, m is log a y. What is n? n is log a x. Now, what is this? This is the law number 1. In logarithms, you can use this law. So that's law number 1. What it says? In logarithms, when you get same base, multiplication inside becomes addition of the separate logarithms. So can you remember in index notation the first law? When you multiply the numbers, you add the power. So this is like reverse of that. When you take multiplication, how can we separate it? You can use addition of logarithms. So here, remember this one, law number 1. When you get equations in logarithms, you can easily solve using this law. Now we'll take this one. We'll try to apply this. We know LG means, what's LG? Base number 10. Now multiplication is there. Two numbers multiply. How can we write down? What's the law number 1 in logarithms? When you get multiplication inside logarithms, you can write as addition of logarithms. So I can straight away write this one as log 8.71 plus log 4.53. What about this one? This is multiplication. 3 numbers multiply. How you do? You can use law number 1. I can write LG 9.3 plus LG 6.5 plus LG 7.2. So here, can you see, according to law number 1, any multiplication inside I can rewrite as addition of separate logarithms. Now we'll take another one. Now other way round given. Addition of logs. How can we write as a single logarithmic notation? I can put LG instead of addition. What is inside? I can put multiplication. What about this one? Two separate additions are there. I can write as a single log notation by multiplying these two together. So 26.7 multiplied by 31.7. Now we'll look at another law in logarithm. So here we'll try to use the previous logarithmic law. How can I write x squared? I can write x into x. But we know according to the first law, what is multiplication inside? I can write this one as addition. I can write log ax plus log ax. Then same log values addition means I can rewrite this as 2 log a base x. Now take this one. How can I rewrite? I can write as log a base x multiplied by x multiplied by x. According to the first law in logarithms, I can write this one as log a base x plus log a base x plus log a base x. Same term 3 times I can write as 3 log a base x. This one, what can you do? X 5 times. But before that, can you see a pattern? Look at carefully. From the first two, log ax is there, 2 here. This power is 2. Here log ax is there. This power comes here. This power comes there. What can you see? When you get a power inside logarithms, that power comes to the front of the logarithmic sign. So here, can you apply that law here? What happens? Straight away you can write down. If this is x to the power 5, you should get this number in front. You get log a base x. So what happens here? What's the power now? Half. What happens to the power now? It comes to the front of logarithmic sign. So log a base x. So generally what we can say about the second law. So here we can see a pattern. When you get any log a base x to the power m, this power comes to the front. We can write m log a base x. So this is your second law in logarithms. So I'll put 2 as this. So remember, when there's a power, this power comes to the front. Now we'll try to apply that second rule in several questions. So here, first one, there's a power. How can we rewrite? We know that when there's a power, you can take it out. I can straight away write this is 2 LG LG. No need to write LOG. It's given as LG. So LG 3.35. What about this one? You get two numbers and you have to apply separately. You have to apply law number 1 as well as law number 2. First, multiplication. Can you see multiplication? So we can write as addition. LG 2.75 squared plus LG 3.14 to the power 3. Then you can take the power out from the logarithmic sign. So then I can rewrite this as, I can take this 2 out and write 2LG 2.75 plus this 3 I can take it out and write 3LG 3.14. What about this one? These two, they have given separately and you are asked to write in single log notation. So you can apply the two laws other way around. So we know if this is addition, we can use multiplication. But before that, you can't just add these two because there's another number outside. So the first thing, you have to apply law number 2. You have to take inside the log notation and then you can multiply. So remember that. When there's a constant in front, you can't use law number 1. So here what we can do, I can take this one inside. This is also I can take inside. So what can I write? I can write LG 3.75 squared plus LG 1.78 power 3. Now, to separate addition, I can use law number 1. So when there's addition, I can use multiplication inside. So LG, I can write 3.75 squared multiplied by 1.78 to the power 3. So that's how you write down as a single logarithmic notation. Now this one, there's a number in front. So you can't do anything. I have to take this one inside first. So when you take inside, how can we write? I can write LG 24.3 to the power half. This one I can write LG 72.5 to the power 1/3. Now you can apply law number 1. Addition you can write as multiplication by taking these two numbers inside, multiplied by 72.5 1/3. So that's how we can write this one as a single logarithmic notation. Now we'll look at the next law in logarithms. So we did 2 laws. Now we'll try to find out the third law. We'll take numbers like this. I'll take x as a to the power m. And I'll take y as a to the power n. So I know I can write down this one in log notation as log base a, and then this number goes there is equal to m. What about this one? I can write this in log notation log a base y is equal to n. Now I have two equations. Earlier I did multiplication. Now I want to see what happens to division. So I am trying to divide now. 1 divided by 2. So what happens? X over y becomes a m over a n. I know this is first law of indices. same base, different powers division, you subtract the powers. I get m minus n. Now we'll apply the first law. How can I write down this one in log notation? I can write log a base. This is the number now I'm getting. X over y is equal to m minus n. Now from these two I can write what is m and n using log notation. So what is the law I'm getting? Log a base x over y becomes m is log a base x minus log a base y. So here this is the third law you have to remember. So what is the law? When you get same base and inside division, you can write as separate logarithms with subtraction. Earlier multiplication you can write as addition of logarithms. Here division you can subtract the logarithms. So remember that, and we'll see how we can apply this law. Now we'll take this one. Now you have given division. So we can try third law. What can I write? I can write instead of division, I can write as subtraction. I can write LG 78.3 minus LG 4.75. What about this one? Now multiplication and division both together. So I can apply law number 1 and 3 together. So how can I write? First thing I can write this one as addition. Log LG 23.7 plus LG 2.75. Now what happens? The division part I can straight away write down as subtraction. LG 5.34. So whatever you get multiplication I can add, division parts I can subtract. Now how can I write this one? I can write straight away LG 2.14 plus, because this is multiplication, LG 3.19. You can subtract the division parts, LG 2.33, and again you can subtract LG 1.72. Now look at this one. Now the subtraction is given. So reverse process. If this is subtraction, you can write as division. So you can straight away write down this one as LG, this number divide by 29.7. What about this one? You can straight away write down. Use law number 1 and law number 3. This number is positive and here negative means division. So here this number goes down. This is plus. Plus means multiply. Again here negative means it should be in the denominator. So 1.22. So this is how we can use law number 1 and law number 3. Now we'll try to form another equation, logarithmic rule. Earlier we did multiplication, division and power. Now we'll look at another rule. We know in index notation 2 to the power 0 is 1. 7 to the power 0 is 1. And any number minus 1 to the power 0 is 1. That means any base to the power 0 is 1. Now, how can we write this in log notation? We know when you are writing in log notation, log, this is the base. Base 2, number 1 is equal to 0. What about this one? Log, what's the base? 7, 1 is equal to 0. What about this one? Log base minus 1, 1 is equal to 0. So, what can you say about this one? Look at the pattern. Any log base, this is always 1. If the value inside logarithm is 1 for any base, you get the answer as 0. So, here we can write general one. If you get any base with 1 here, you get always 0. So, this is the law number 4. So, here for example, if this is log 20, 20 base 1, what's the answer? You get 0. Any base, you can write log 5 base 1, that's 0. So, here try to apply when you get any number as 1 for any base, the answer becomes 0. Now, we look at another law. We know that 3 to the power 1 is 3. 10 to the power 1 is 10. 7 to the power 1 is 7. Try to write down this one in log notation. Log, here this is the base. Base 3, the value becomes the index. What about this one? Log, base 10, the value is 10, that's equal to the index. This one, log 7 base, the value is 7, that's equal to 1. What can you see? For any base, these two are equal. Then you get always the answer as 1. So, if this is any base A, we know this is A, you can say log, same base with same value inside, you get 1. So, this is the law number 5. So, remember that, for example, if this is log 3 base 3, you get 1. Log 20 here, if these two are equal, you get 1. So, now we did 5 laws of logarithms. So, we will try to apply these in questions. Now, can you remember we didn't do review exercise question number 3 and 4 because that was related to logarithms. Now, we will try to use laws of logarithms to solve these expressions. Here, basically simplify these expressions. So, question number 3 says simplify. So, here first one, addition is there. What's the law number? That's the law number 1. When it's addition, you can straight away write down multiplication inside. So, how can I write down 25 times 4? You get 100. So, LG, what is LG? This is log 10 base. Can we simplify this one further? 100 is what? We can write as 10 square. Now, according to law number 2, we know when there's a power, you can take it outside. I can write 2 log 10 base 10. Now what is this one? The other law. When you get same base, same number, the answer becomes 1. So 2 times 1, I can write as 2. This one, same base given, but subtraction. So subtraction becomes division. So you can write 8 over 4. When you simplify this, 4 and 8, you get 2. What is log 2 base 2? Same base, same number, you get 1. This one, base 5 is given. Addition and subtraction. So what is the rule? When it's addition, you multiply. When it's subtraction, you divide. So here 50 and 2 in the numerator and 4 goes there because that's division. Now try to simplify. 4 times this one, you get 2. 50 divided by 2, you get 25. So log 5 base 25. Again, you can simplify further. 25, how can I write? I can write as 5 squared. Now, according to law number 2, this 2 I can take it out. 2 log 5 base 5. What is this law? When you get same base, same number, the answer is 1. So 2 times 1, final answer is 2. Now look at this one. Same bases are given, so you can simplify. How can I write this? LOGA. 5 and 4 addition, that means multiplication. What about this one? Subtraction means dividing by 2. Now simplify, you get 2. 5 times 2, 10. Can we simplify further? No, this is a number and this is a letter. You can't simplify further. What about this one? What's the base? X is the base. So here addition becomes multiplication, subtraction becomes division. So simplify. 3 times 4, 4 times 4. What you get? 16. Now look at the other one. Same base is given. So log P. Here multiplication is addition of these logarithms. So I can write A times B and C is with subtraction. I can divide this by C. So what's the final answer? I can write log P base AB over C. Now look at fourth question. Solve the following equations. Now you get logarithmic equations. I can first simplify this side. This is addition. Addition of logarithms, you know, that's multiplication. So what's that? Log 5 base x is equal to log 5 base 8. Now according to equations, you get same log values with the same base. So you can, when you compare the two, you can equate the two numbers inside because both are equal. So what can I write? I can write x is equal to 8. What about this one? I can use the law. Subtraction becomes division. Here base is 5. Here I can write the same thing. Then 2 and 4, you get 2. So here log 5 base 2 is equal to log 5 base x. Same base and this is an equation, you can compare the inside value. So x becomes 2. This one, log a base is there. Addition. Addition becomes multiplication. So what's the next step? If both are equal, you can compare the inside value. So I can write 2x equals 10. So what's the x value? I can divide this by 2 and write 5. Now look at this one. Try to apply separately left hand side and right hand side. This one addition, I can write as multiplication. I can write 10x. What about this side? These two multiplication and this one is division because that's a subtraction. Now simplify 2 times 3. So what you get? Log 3 base 10x is equal to log 3 base 5 times 3 is 15. Now 3 base, same base. So you can compare the inside value. So I can write 10x equals 15. When you divide by 10, you get x. So when you simplify 5 times 2, 5 times 3, you get 3 over 2. E. Now LG. What is LG? Base 10. So I can write these three as LG 5 multiplied by 8 and divide by x because x is minus. This is equal to LG 4. What can I do? I can compare the inside values. I can write 4 times 8 is 40 over x is equal to 4. Cross multiply, I get 40 equals 4x. When you divide both sides by 4, I get x equals 10. This one, again, apply the same thing. But there's a small problem here. Base 5, this is base x. So you can't apply the law for these two because bases are different. You can apply the laws only the bases are equal. What I can do, I can take this one to the other side. So you get log x12 is equal to, I can add this to 3 plus log 5 base 4. Here you can apply the law. Same base, addition you can multiply. So I can write 3 times 4, 12. Now what can we see? Inside numbers are equal. So here to get inside numbers equal, this x should be 5. Only way this is equal is by equating these bases. So x should be 5 to get the answer. Now we look at another pattern in logarithms. Okay, we'll take 10 to the power 3. What is 10 to the power 3? 1000. When you take log notation, what can you see? Log 10 base 1000 is 3. Take power 2, you get 100. When you take log notation, log 10 base 100 is 2. 10 to the power 1 is 10. Log 10 base 10 equals 1. We'll take 10 to the power 0 is 1. Log 10 base 1 is equal to 0. What about the other one? 10 to the power minus 1. What is 10 to the power minus 1? We can write 1 over 10. So I can write log 10 base 1 over 10 is equal to minus 1. Again 10 to the power minus 2, 1 over 100. If I look at the logarithmic one, this is 10 base 1 over 100 is equal to minus 2. Now can you see a pattern there? Look at carefully. So that's 10 base. This is number of zeros. If it's 1000, 3 zeros are there. If it's 100, 2 zeros. So here, when you get something like this one, multiples of 10, and also any power, it can be negative or any power, the answer is always equal to number of zeros. So here, straight away, you can use that property. This is 3 zeros, the answer is 3. If this is 2 zeros, the answer is 2. If it's 1, 1. Here, this one, you get 0 because 1 to the power. There's no zeros there. Here, 1 over 10 means 10 to the power minus 1. So here, you get minus 1 value. 1 over 100 means you get minus 2. So when you get any numbers like 1000, 100, any 10 to the power something, just look at how many zeros are there and you can get the logarithmic value at once. Now we'll apply all these log laws to find out these answers. So here in the first one, it says LG25 plus LG4. What's the law we can use? We can use the first law. What's the first law? LG25 times 4, that's LG100. Now, according to the previous pattern we saw, LG means 10 base. If it's 10 base, 100. What's the answer? 2 zeros are there. So you can straight away write down this is 2. This one, can we apply the law at once? No, because there's a number in front. First thing, you have to take this one inside. So when you take this one inside, what you get? We get LG24, LG3, LG2. Here when we take 2 inside, so what you get? LG 5 squared. 5 squared you can write 25. Now we can apply the laws. We know addition becomes multiplication, subtraction becomes division. So straight away I can write LG 24 times 25 because that's positive, divide by 3 and 2. So when you simplify, what you get? 3 times 8, 2 times 4. 4 times 25 is 100. So LG 100. According to the rule, you count how many zeros are there. So you get straight away 2. LG means base 2. This one, apply the law. Straight away you can apply for these 4, not for minus 1. We'll try to find out LG 60 multiplied by 25 because this is plus. Divide by 5 and 3 and you get minus 1. Now try to simplify. 3 times 20, 5 times 4. 4 times 25 is 100. LG 100 minus 1. So what is LG 100? LG 100 is 2. 2 minus 1, you get answer 1. Now we'll look at another question. Here straight away we can't apply the laws because there's a number. So first thing, you can take this one inside. So when you take this one inside, how can I write? I can write LG 8 to the power 1/3 plus LG 25 to the power half. Now we know this is addition. You can straight away write down as multiplication. 8 1/3 multiplied by 25 to the power half. Now what is 8 to the power 1/3? We know 8 is 2 to the power 3 and 3 get cancelled out, you get 2. So you get straight away, this is 2, 25 square root, you get 5. So LG10, what is LG10? When you get base 10, you just count number of zeros. So here number of zeros is 1. Now look at this one. You are asked to solve these equations. When you get log equations here, straight away you can convert to index notation and solve for x. I can write this one in index notation as I told you the pattern I saw. X is 2 to the power 3. Remember this one? Log 100. Log 10 squared is 100. Log 10 base 100 is 2. So 10 squared is 100. So similarly, 2 to the power 3 should be equal to x. So what is 2 to the power 3? You get 8. This one, how can I write in index notation? X to the power 3 is equal to 8. Now I can write 8 as 2 to the power 3. So here, same power you can equate to these two numbers. So x equals 2. Now look at this one. You have given an equation to solve. So what's the first step I can do? I can use the law. Addition becomes multiplication. What about this side? Again addition becomes multiplication. Same log notation, you can compare the inside. So 3x is equal to 12 times 7. So what is x? I can divide by 3. So x equals 12 multiplied by 7 divided by 3. What you get? 3 times 4. 4 times 7 is 28. Look at this one again. You can apply laws of logarithms. So here I can write subtraction as division. This side also subtraction as division. Then I can simplify this side. So here same logarithmic notation, I can compare the inside value. So I can write x over 2 is equal to 3. So what is x? I can multiply by 2 and 3. You get x equals 6. Now we'll look at this question. Again, you have given an equation and ask you to solve for x. Can we apply the laws for left hand side? You can't because there's a number now. What's the first step you can do? You can take that inside. So first thing we'll do that LG x squared plus LG 3. Now you can apply for the right hand side, you can apply the laws of logarithm. So here this is addition. Addition becomes multiplication. 6 times 2, you get 12. Here also addition, you can multiply. 3 times x squared, I get 3x squared. Now both sides logarithms with same base. You can compare the inside value. So I can write 3x squared as 12. When you divide by 3, you get x squared is 4. What's the square root of x? X becomes plus or minus 2. Here, can we get minus 2? Now the x value is minus. Here you need to remember one thing. We can't find log of negative values. That's undefined. So here we have to take only the positive answer. So this value should be x equals plus 2 because LGX, x cannot be inside in the logarithm cannot be negative. Now we'll look at the next one. In this question, you have given x is this, y, z. You are asked to find out the value of x plus y plus z. So we'll substitute. What is x? Lg 2/3. What is y? Lg 3/5. What is z? 2Lg square root 5/2. Now what we can do? We can't apply laws because there's a 2 here. So we have to take 2 inside. So I'll rewrite this 2/3 there, 3/5 there. And when you take 2 inside, square root and square term, what happens? Squaring the square term, it get cancelled out and you can write Lg 5/2 because square root of 5/2 square it is 5/2. Now you can apply the law. Addition means multiplication. So this becomes 2/3 multiplied by 3/5 multiplied by 5/2. So when you simplify, what you get? 2 get cancelled out. 5 get cancelled out and 3 get cancelled out. You get Lg 1. According to the law, any base with 1 is always 0. So the answer for x plus y plus c becomes 0. Now we'll take example number 1 in your textbook. It says evaluate. Evaluate means you need to find the answer. So here Lg 1000. What did I tell you? When you get 10 base, you just count the number of zeros. So this is 3. But if you want to show the method, I can use this one as 10 to the power 3. Then I can take power 3 out. 3 Lg 10. Lg means 10 base. Same base and same number, this becomes 1. So what's the answer? You get 3. This one, log 4 base. 64 cube root. You can write 64 to the power 1/3. Now can you see 64 1/3 cube root of 64? We can simplify that. I can write this is as 4 to the power 3 as 64. I see that it get cancelled out. Now what's the answer? Log 4 base 4. Same base, same number, you get 1. Now look at the other one. Numbers are there in front, so you can't use laws at once. So first thing, you have to take these ones inside. So I can write this as 2 to the power 2. This one as 4 to the power 3. This one as 8 to the power 2. Now I can apply the law. I can write same base 2 to the power 2 times 4 to the power 3 divided by 8 squared. Because addition becomes multiplication, subtraction becomes division. Now try to simplify. 2 squared is 4 and 3 fours are there. I can write like this. 8 squared, 8 and 8. 4 times 2, 4 times 2. 2 times 2, 4. Get cancelled out with this 4. So what you get? Log 2 base 4. 4 you can write as 2 to the power 2. Now I can take this one out. So what's the answer? I can write 2 log 2 base 2. So what is same base and same number? You get 1. So the answer is 2. Now we'll look at example number 2 in your textbook. So here it's given 2LG8, 2LG5. So when there's a number here, you can't use loss. So what we can do, I can take 2 inside, here also 2 inside. So first step is I can write 8 squared and 5 squared. This one I can use laws of logarithm. Addition becomes multiplication. I can write 4 to the power 3 times x. What's the next step? This is addition. I can multiply. So LG. Addition becomes multiplication. So I can write 8 squared multiplied by 5 squared is equal to LG 4 to the power 3 x. Now, when you want to solve this, you can compare the inside part because LG means same base logarithm. So I can write 8 squared into 5 squared is equal to 4 to the power 3x. So what is x? 8 times 8 times 5 times 5 divide by 4 to the power 3. I can write 3/4. Now try to simplify. 4 times 2, 4 times 2. And 2 times 2, 4, and this 4 get cancelled out. So what's the answer? I get x equals 5 times 5 is equal to 25. Now look at this question. Again, there are numbers in front. So the first step is to take the numbers inside. So what's the first one? I can take this one inside. This becomes 3 squared. What about the next one? LOGB base 2 to the power 3. Then this one 72. This also you can take inside. LOGB base x to the power half. Now you can apply laws of logarithms. I can write LOGB, these two multiplication, and this one division because that's subtraction. Then I can write log GB is x to the power half. Then you can compare the inside values because same log values given. So I can write this side as 3 squared is 9, 2 to the power 3 is 8 is equal to x to the power half. What is this side? 8 times 9, 72. 72 get cancelled out, you get 1. So x to the power half is 1. How can I get x? You can square both sides. When you square both these sides, you get x equals 1. Now we'll look at example number 3. You are asked to verify. So that means you can either take left hand side separately and right hand side separately and show that both sides are equal. Or I can take all log terms to one side and show that it's equal to 1. So we'll take separately left hand side and right hand side. So I'm getting, we'll take left hand side first. Left hand side. So when you take left hand side, you can use laws of logarithms. I can write log 5 base 75 divided by 3 because this is subtraction. So when you simplify, what you get? Log 5 base 75 divided by 3, I get 25. Then again 25 I can write as log 5 base 5 squared. Then this 2 I can take it out and write 2 log 5 base 5. So what is 5 base 5? Same base, same number. This becomes 1. So 2 times 1, I get 2 as the left hand side value. Now we'll take the right hand side value. So what's the answer? We can take the right hand side and apply the plus 1. Now we'll use the laws of logarithms to this one. You get log 5 base. This is subtraction, becomes division, plus 1. So 8 and 40, you get 5. Same base, same number, you get 1. So 1 plus 1, what you get? 2. So left hand side is equal to 2, right hand side is equal to 2. So you can write right hand side is equal to left hand side. So this is equal. That's how you verify an equation. Now we'll look at exercise 2.3 in your textbook. It says evaluate. Evaluate means find a solution. Base 2. That means if you can write 32 in terms of 2, you can simplify further. What's 32? 2 to the power 5. Then I can take 5 outside and write log 2 base 2. What is same base, same number? This becomes 1. 5 times 1, you get the answer 5. Here LG means 10 base. I told you when you get any multiple of 10s, you count how many zeros are there. 1, 2, 3, 4. Answer should be 4. But we'll do using laws. This becomes 10 to the power 4. We can take 4 out. 4 LG 10. Same base, same number, you get 1. So this becomes 1. 4 times 1, you get 4. This one, there's a number 1/3. So you can take this one inside. This one, take inside first. Then 27 cube root. What is 27? I can write this one as 3 to the power 3 into 1/3. I get log 3 base 3. Same base, same number. I get 1. Now we'll look at this question. Half log 5 square root 25. We'll try to simplify inside. We'll keep half there. What is square root means? 25 to the power half. Okay, so now I can take half outside. Half times half, I get 1/4. Log 5 base 25. Again, 25, how can I write? I can write, this is 1/4, 5 squared. Again, I can take 2 out. So what you get? 1/4 times 2, log 5 base 5. What is 5 base 5? You get 1. So what's the answer? 2 times 1, 2 times 2, you get half as the answer. Now take this one. 4th root is there. So we'll write down in index notation 81 4th root. So we have to think about what's 81 in terms of a number to the power 4. So what's the number? You can write 3 to the power 4. When you multiply by 4, 4 get cancelled out. So you get log 3 base 3. Same base, same number, you get 1. What about this one? In this one, we'll take 3 inside. What happens? Log 2 base. This is square power 1/3. Cube root is there. So we can write 8 to the power 1/3 and you are taking power 3. Because when you take 3 inside, that becomes power 3. Cube root and power 3 get cancelled out and you get log 2 base 8. Now, how can I write 8? I can write 8 as 2 to the power 3. And then I can take 3 out. When you take 3 out, I get 2 base 2. So 2 base 2, same base, same number, I get 1. 3 times 1 is equal to 3. Now we'll look at second question. It says simplify each of the following expressions and find the value. So here, when you want to simplify, first thing, you have to get rid of these 2. How can we do that? We can take that number inside. So log 2 base 16. So 2 goes as the power. Now what's the next step? You can use the laws of logarithms. Subtraction you can write as division. Now try to simplify. 16 squared means 16 times 16. Divide by 8. 8 times 2. 2 times 16, it's 32. So log 2 base 32. 32, how can I write? I can write as 2 to the power 5. So log 2 base 2 to the power 5. I can take this outside. So what you get? 5 log 2 base 2. Again, same base, same number. You get 1. 5 times 1, you get 5. Now look at the next one. So the next one is LG80 minus 3LG2. There's a number in front. First thing, you have to take that inside to apply laws of logarithms. LG80 minus. When you take 3 up, what you get? 2 to the power 3. Now apply the law. Subtraction becomes division. 2 to the power 3 is 8. So 80 divided by 8, you get 10. What is LG10? Same base, same number. You get 1. This one, there are numbers in front. So you have to take inside. So first thing, take these inside. I can write LG 5 squared, LG 2 cube. Then you can apply the laws of logarithms. I can write LG as 5 squared multiplied by 2 to the power 3 divided by 2. Now to simplify, I get LG 5 squared is 25, 2 to the power 3 is 8 divided by 2. 2 and 8, I get 4. 25 times 4, 100. So you get LG 100. So this one is, I told you to say 10 base, you count how many zeros. So you are getting 2. Or you can write 100 as 10 squared and take 2 outside. So you get the answer as 2. What about this one? There's no numbers in front. So straight away you can apply the law. I can multiply this with 28 and divide by 3 and 7. Now try to simplify. 7 times 4. 3 times 75, you get 25. 25 times 4, you get 100. So what is LG 100? Count number of zeros. You are getting 2. Or you can rewrite as LG 10 squared and take the power out. 2 LG 10. LG 10 becomes 1. 2 times 1, you get the same answer. Now we'll look at this one. You are asked to simplify. So there are numbers in front of the log notation. So first thing, take all these inside and rewrite. You get LG 3 cube plus LG 9 to the power half plus LG 5. Now the second step is just simplify. I can write 3 to the power 3 as 27, square root of 9 as 3, and then I can apply the laws of logarithm. So what you do? Multiply when it's addition. I can multiply by 3, multiply by 5 and divide when it's negative. Simplify now. 3 times 1, 3 times 9. 9 times 2 is 18. So 2 times 5, 10. LG 10. Same base, same number. You get 1. Now look at this one. Again, numbers in front. So take it inside. So I can rewrite this as 2 to the power 4. Then apply the laws. I can write LG. 2 to the power 4 is 16. Multiply by 15 over 4. Divide this by 6. Now try to simplify. 4 and this, you get 4. And divide by 2, 2 and 3. So what's the answer? You get LG. Here again 3 and this, 15, you get 5. 5 times 2, 10. LG 10. What's the answer? LG 10 is 1. Now look at this one. 3 is outside. You have to take that inside. So I can rewrite this as 1 over 256. You can write the same thing, but this one I can take this one inside. So I can write minus LG 1 over 20 to the power 3. Now try to simplify. First thing, I can use the laws of logarithms. I can use LG. Subtraction. This and these two subtracting means this one comes to the numerator and these two goes to the denominator. What is 20 to the power 3? 20 times 20 times 20. So you are getting this one. So we'll try to simplify now. What you get? Here I can do divide by 5. 5 times 2, 10. So 5 times 5. So this is 5 times 4. Again divide by 5. This is 4. This is 5. Again divide by 5. I get 4. So you get LG 1 over 256 divide by 1 over 4 fourths. So when it's division, what happens? You have to take the reciprocal. So you get LG 1 over 256. What happens to division sign? It becomes multiplication and you take the reciprocal. So you get 4, 4, 4, 4 as the numerator. So here simplify this. So here when you divide by 4, you get 4 times 6, 24, 4 times 4. Again divide by 4, you get 16. Again divide by 4, you get 4. This 4 get cancelled out with this 4. Finally what you get? LG 1. So what is LG 1? According to the rule, what is LG 1? This is no zeros, so you get any base 1, the value is 0. Now we'll look at this one. There's 2 outside. So first thing, you have to take this number inside. So here log 327 plus log 3, 2 goes up and you can write 3 squared. So 3 squared is 9. Then what's the second step? Apply the law. You can write log 3 base. Addition becomes multiplication. Subtraction becomes division. Now simplify. 3 times 3, 3 times 27. 3 times 27 is 81. So here you can write log 3 base 81 or simplify further. 81 I can write 3 to the power 4. When you take 4 out from the log notation, I can see same base, same number becomes 1. 4 times 1, the answer is 4. Now we'll look at this question. So there are no numbers in front. So straight away you can apply the laws of logarithm. So what's the logarithm? LG. So you can multiply when it's addition. You can divide when it's subtraction. Now try to simplify this. 5 times 5, 3 times 4, 3 times 7. Then what else I can do? I can see LG 4 times 5, 20 over 7. Divide by 2 over 7. Simplify. LG 20 over 7 multiplied by, take the reciprocal of this. 2 and 20 you get 10. 7 get cancelled out. LG 10. So what is LG 10? You get same base, same number. You get 1. This one, there's a number in front. So the first step is to take this inside. So what's the number? LG 3 over 4. This one I have to take as 3 over 10 squared. This one you can write as it is and write minus 2. Now you can apply the laws of logarithms. I can do LG 3/4. This one multiplication because that's addition. And this one becomes division. 3 times 3, 9. 10 times 10, 100. And minus 2 is there. Now try to simplify this. 4 and 12 I get 3. Then LG 9 divide by 9 over 100. What's that? I can rewrite as LG 9 multiplied by 100 over 9. 9 get cancelled out and you get LG 100. What is LG 100? You know how many zeros are there? 2. LG 100 is 2. 2 minus 2, you get 0. Now we'll look at question number 3. It says solve the following equations. So here look at the first one. LOG, LG. Here normally we write LOG as LG. So we'll take, this is the same thing. So we'll first write this is LG. If the bases are different, you can't do this sum. So we have to assume that LOG is same as LG. Now you can apply laws of logarithms. Addition becomes multiplication. So I can write 4x, 4 times x. What about this side? Addition is multiplication. 8 times 2, 16. Now you are comparing the two logarithms. When you compare same bases and same logarithmic sign, you can compare the inside. 4x equals 16. So what's x? Divide by 4. 16 divided by 4, you get 4. Now look at the next one. You get numbers outside. So the first thing, you have to take the numbers inside. I'll take this one inside, this one inside. So I can write LG 2 to the power 4. What's 2 to the power 4? 16. Here I can write LG x squared plus LG 5 is equal to. This one I can use laws of logarithms. 15 and plus 12, you can multiply 15 times 12. This side also I can apply laws of logarithms. I can multiply 16x squared times 5. Now, both sides you get the same logarithmic values. So, you can compare the inside values. So, here 6x squared into 5 should be equal to 15 times 12. Then, what is x squared? X squared is 15 times 12 divided by 16 times 5. So, when you simplify, what you get? 5 times 1, 5 times 3. 4 times 3, 4 times 4. So, what's the answer? You get 9 over 4 as x squared. So, what's the square root of 9? 9. You get 3. What's the square root of 4? You get 2. When you take square root, you can get plus or minus. But here you can't take the negative value because x is inside the logarithmic sign. So, you have to take only the positive answer. Now, look at this one. Again, there's a number in front. First thing you have to take inside. Here also you have to take inside. So, what's the first step? You take 3 up, that's x cube. What about this one? You can write as it is. This one also you can take 2 inside, 9 squared. So, what is 9 squared? 81. Now, you can use laws of logarithms. I can write LG addition. Addition becomes multiplication. Here also I can write LOG is same as LG. So, no difference. And here I can write LG instead of LOG, and this is also multiplication because this is addition of logarithms. Now, you can compare the inside values. So, you get x cube into 96 is equal to 81 times 4. So, what is x cube? You can divide by 96. Now, try to simplify. 4 times 1, 4 times 2, 8. For 16, that's 4. Now, we can see you can divide by 3. 3 times 8, 3 times 2, 6, and you get 21, that's 7. So, you get 27 over 8 as x cube. So, how can we find out cube root? Cube root means x. X is equal to 27 cube root and 8 cube root. So, what is 27 cube root? You know that's 3 is the answer there. Cube root of 8, that's 2. So, what's the answer for this one? 3 over 2. Now, we'll take this one. Here also you get numbers in front. So, first thing is to take these one inside and rewrite this. You can write 2 to the power 4, that's 16. X to the power 2. And this one you can apply the laws of logarithms. Addition becomes multiplication inside. Now again you can apply the laws of logarithm here. So all positive, that means multiplication. That's equal to LG 15 times 12. Now, what's the next step? You can compare the inside values. So, 16x squared into 5 is equal to 15 times 12. Then how can we find x squared? Make x squared as a subject. You get 15 times 12 divided by 16 and 5. So, you get 5 times 1, 5 times 3. 4 times 3, 4 times 4. So, you get 9 over 4 as x squared. So, how can we find out x? Square root of these two numbers. Square root of 9 is 3. Square root of 4 is 2. So, what's the answer? 3 over 2. Here also, you can't take the negative value when you take the square root, because inside cannot be negative. Now we'll look at the next one. Again, you are asked to solve for x. So what's the first thing we have to do? If there are numbers, you have to take inside. Then rewrite this LG, I can write x cube. This one I can write 8 squared. What about this side? I can write 48. This one as LG 25 power half minus LG 30. Then I can apply laws of logarithms. Addition becomes multiplication. Here also addition becomes multiplication. But we know square root of 25 is 5. I'll write 5 there. Divide by 30. Now we see that 2 log terms, so you can compare the inside values. So I can write x cube into 8 squared is equal to 48 times 5 divided by 30. I see you can simplify further. 5 times 1, 5 times 6. Then how can I find x cube? I can take 8 squared down. So here I get 48 over 6 divide by 8 squared. 8 squared I can write 8 times 8. Now try to simplify. 4 times 2, 4 times 12. 6 times 2, 12. And this 12 get cancelled out. Say what you get. I get x to the power 3 is 1 over 8. So cube root of 1 over 8 you get as x. So what is the cube root of this one? 8. I get 2. 2 times 2 times 2 is 8. So I get 1 over 2 as the answer. Now look at this one. In this question, there are numbers outside. So first step is to take these inside. So here what you get? You get 125. These 2 you can take inside. So you get 3 squared. What about this one? LG, I can take 2 inside. Now, what's the next step? I can use laws of logarithms. I can write LG 125 times 3 squared. Here I can write LG x squared times 5, because addition you can write as multiplication. Now you can compare the inside values because you get same logarithmic form. So I can write 125 times 3 squared is equal to x squared times 5. How can I find x? X squared. 125 times 3 squared is 9 over 5. 5 times 2 and you get 25, that's 5. So x squared is 25 times 9. When you take square root, you get square root of 25 is 5, square root of 9 is 3. So what's the answer? You get 15 as the answer for x. Now we'll look at the miscellaneous exercise in your textbook. The first question says find the value. So radical form is given, so you have to convert to index notation and simplify. So here small 3 means power is 1/3. So 1/3 is the power. So I can write 8 to the power 1/3 squared. What about this 3? Again, that's power 1/3. Now we need to find out 8 as what's the power of a number that's equal to 8. And you have to think about power 3. We know 2 to the power 3 is 8. When you multiply by this number, you get this one, and here 27 I can write 3 to the power 3 into 1/3. I see these 3 get cancelled out. 2 to the power 2 is 4 and 3 to the power 1 is 3. So the answer is 4/3. Now we'll look at this one. 125 square root and power 3 is there. So what can I write? I can write 125 3/2. 20, how can I write here? Square root. Square root I can write power half. 10 I can write as it is. So here I can write this one as, what are the prime factors for 125? I can divide by 5 and divide by 5 again and 5 again. 5 to the power 3. But this one, how can I write 20? 20, when you divide by 2, divide by 2 again, 2 to the power 2 and 5. So here I can write this one as 2 to the power 2 and 5 to the power 1. And you get power half. This one, the first one, how can I write? I can write this one 5 squared into 5 and then 3/2. Now we'll take separately. So I can take the power separately. I can write 5 squared multiplied by 3/2 and again 5 3/2 into 10. In the numerator, what about denominator? I can take power half for both of these numbers. 2 to the power 2 into half, 5 to the power half. Now I see this one get cancelled out. So you get 2. 2 and this 10, I get 5. And also this 2 and this 2 get cancelled out. You get 5 to the power 3. So what is 5 to the power 3? I'll write as it is, 5 to the power 3. And here, can you see 5 to the power 3/2 there and another 5 to the power half there and again 5. So here, this is what you are getting. Now, you can apply laws of indices. Same base, different powers, multiplication. You add the powers. When you get division, you subtract the powers. So here, look at the numerator and simplify. You can add all these powers. So you get 3 plus 1, 4. And here you get 5, 3/2. And now look at these two. These two you can subtract. 3/2 minus half, what you get? These two, when you subtract, you get 5 to the power 4 and 3/2 minus half, you get 2/2 or just 1. So you get 5 to the power 1. So what's the final answer? You get 5 to the power 5. So what's 5 to the power 5? 5 times 5, 25. 25 times 5, 125. 120 times 5, you get 625. So how many 5s we multiplied? This is 4. Again you need to multiply by 5. 5 times 5, 25. 2 remaining. 5 times 2, 10 plus 2, 12. 5 times 6, 30. 30 plus 1, 31. So what's the answer? 5 to the power 5 is 3125. Now we'll look at the second question. The third part. In this part, again radical forms given, you have to simplify it. So we'll try to do that. So 32 with minus 2/5 there. So if I can write 32 as a power of 5, I can simplify. So 32 is 2 to the power 5. So I can write this one as 2 to the power 5 multiplied by minus 2 over 5. 216. Can I write as any number to the power 3? What's 216? 6 times 6? 36. 36 times 6? You get 216. So I can write 216 as 6 to the power 3. What about this one? 81. I need a number to write 81 as power of 4. So what's the number? 3 to the power 4 is 81. So I can write 3 to the power 4. What about this one? 8 to the power 0 is there. 8 to the power 0 is 1. 1 and then you have to take the cube root of 1. Cube root of 1 is 1. This one becomes 1. Then this one, we have to take the power. 27 minus 2 is there. Cube root means you divide by 3. Now we'll try to simplify further. 5 get cancelled out. This 3 get cancelled out. So what you get in the numerator? 2 to the power minus 2, 6 squared. What about the denominator? 3 to the power 3. And here again you can simplify. What is 27? 3 to the power 3 times minus 2 over 3. Again this 3 get cancelled out and you are getting 2 to the power minus 2, 6 squared over 3 to the power 3 and 3 to the power minus 2. Now I can simplify these two. Same base, different powers multiplication, I can add. So here I am getting 2 to the power minus 2, 6 squared. 6 squared is 36 over. When you simplify this one, 3 minus 2, you get 1. So you get 3 here. When you simplify this, 3 with this, you get 12. Now there's a negative power. I can switch and write down as a positive power. So I can write 12 there. 2 to the power 2, I can put it down. So 12 divided by 2 to the power 2 is 4. 12 divided by 4 is equal to 3. Now we'll look at this question. 18 into 5 squared over 8. And you are asked to take the square root value. First we'll simplify inside. I can see you can divide by 2. You get 4, you get 9. Then I can rewrite this one as 9. 5 squared is 25 over 4. How can we get the square root? We can take square root for all these numbers. Square root of 9 is 3. Square root of 25 is 5. Square root of 4 is 2. So what's the final answer? 3 times 5, 15. Divide by 2. Now we'll look at this question. So you are asked to find out the value. Again, when there's a power, you have to consider for all these numbers inside. 1 to the power, any power is 1. 8 to the power minus 1/3 comes. Then 5 to the power minus 2 and 100. Now 8 can we write as any number to the power 3? Yes, we can write 2 to the power 3 into minus 1/3. Here 5 to the power minus 2 into 100. Here 3 get cancelled out. So what you are getting? 5 to the power minus 2 into 100 over 2 to the power minus 1. You get negative power, so you have to convert to positive powers by taking the reciprocal. So here 100 is there. You need to switch places. This goes up and this goes down. So you get 5 squared. Now try to simplify. 100 times 2, 5 times 5. 5 times 5, 25. 25 times 4, 100. So 4 times 2, What's the answer you are getting? You are getting 8. Now look at the other question. 27 to the power 2/3 and 16 to the power 3/4. Try to write down 27 as power of 3, 16 as power of 4. So how can I write? I can write this is as 3 to the power 3 and 2/3 comes. 16 I can write 2 to the power 4 and 3/4 comes. 3 get cancelled out, 4 get cancelled out. What's the answer? 3 squared minus 2 to the power 3. 3 squared is 9. 2 to the power 3 is 8. 9 minus 8, you get 1. Now we'll look at the second question. It says simplify and express using positive indices. Okay, so here square root sign is given. So what it means? It means we have to take power half. Now consider power half for all these numbers. So here I can take 2 times half and minus half into half. Then what's the next step? I can simplify this. I get A. What about B? I get minus half times half minus 1/4. But I can't keep this answer in negative index notation. So I have to convert to positive. So I can take this one down and write this one as 1/4, positive 1/4. Now look at the next one. So in this one, again power half is there. That means you need to multiply by half according to law number 3. So minus 4 times half. This one I can write as square root. So negative 3/2. Now try to simplify 2 and this one 2. I get x to the power minus 2 over x to the power minus 3/2. According to second law, when this is division, I can subtract the powers. I can write as x minus 2 minus 3/2. So what happens to the power? I get plus 3/2. So what's the answer? Minus 2 plus 3/2, you get minus half. So this one becomes minus half, but I can't keep as negative powers, so I can take this down and write half, or I can use the notation, this square root notation, and write 1 over square root of x. Now we'll take the next one. Here you get multiplication, so you can't simplify at once. So what can you say? Here 2 terms, you are getting the same term. One is positive, one is negative. What's that? This is difference between 2 square terms. Can you remember? A plus B, A minus B, we can write as A squared minus B squared. If you get same terms here, you can use square term. So difference between 2 square terms. So straight away I can write x to the power half squared. What's the other term? X to the power minus half squared. Then when you multiply, I get x here. When you multiply this, you get x to the power minus 1. Here you can't write like this. I'll take this one down and write 1 over x. So that's what you are getting. Now we'll look at part D. In part D, we can write down this one. First we'll take x divide by, what is this one? Nth root of x. So I can write 1 over n, and n goes there. Now division, what you do? This is 1. Division becomes subtraction of powers. So I can write this one as x 1 minus 1 over n to the power n. Because division, you subtract the powers. Then what you do? I can write this one as x to the power n over n minus 1 over n to the power n. When you subtract, what you get? You get x to the power n minus 1 over n and power n. When you get brackets, you know we have to multiply by these two. So n get cancelled out and you are getting x to the power n minus 1. Now we'll look at this one. You get two powers. So here, what is this symbol? Square root. This means a to the power 3 over 2, power minus 2 and also power half. We can start from outside. Minus 2 and half, we can multiply. This and this becomes, you get minus 1. So you get a 3 over 2 times minus 1, you get minus 3 over 2. But you can't keep the answer like this. How you convert to a positive number? I can take this down and write a to the power 3 over 2. Now we'll look at question number 3. It says verify the following. So when you want to verify this, you take left hand side separately, right hand side separately and see whether you are getting the same answer. So we'll take the left hand side first. What you get? LG 217 over 38 divided by 31 over 266. Try to simplify. LG 217 over 38 multiplied by division, you can write as reciprocal. 266 goes up, 31 goes down. So what you can do? Try to simplify. Here, can you see 31 times 7 is 217. So what about this one? Can you get 38 times 8? What do you get? Not 8. So 7. 7 times 8, 56. 5 remaining. 7 times 3, 21 plus 5, 26. So here you get 7. Now in this one you get LG 7 squared. So what is 7 squared? You get LG 49. Now we'll see whether we are getting the same answer on the right hand side. So what's the right hand side value? 2LG7. We know that we can take this 2 inside. When you take this 2 inside, I can write LG 7 squared. So what is 7 squared? You get LG 49. So we see left hand side is equal to right hand side. That's how we can verify this equation. Now we'll look at this one. Here, if you want to verify this, you have to take left hand side separately, right hand side separately, and you have to show those two are equal. Now we'll take left hand side separately. You get half LG9 plus LG2. Here we'll take half inside. What can you write? LG9 to the power half. LG2. What is 9 square root? 9 to the power half is square root of 9. You get 3. Now you can use laws of logarithms and write as a single one. 3 times 2. You get 6. So you get LG6 for the left hand side. Now we'll see whether we are getting the same thing on the right hand side. So we'll first take 2 inside and write LG 3 squared minus LG 1.5. Then simplify. 3 squared is 9 minus LG 1.5. Or I can write, instead of writing 1.5, I can write 3 over 2. 1.5 means 3 over 2. 3 divided by 2. Now, subtraction I can write as division. So, LG 9 divided by 3 over 2. So, what is 9 divided by 3 over 2? I can write as 9 divided by 3 multiplied by 2. Because 2 goes to the numerator. So, here simplify, you get 3. 3 times 2, I get LG 6. So, we can see left hand side is equal to right hand side. So, that's how we can verify an equation. Now, we'll take this one. So, left hand side is given in log terms and the other one is 1. So, here basically what we can do, take the left hand side, simplify and show that you get 1. So, left hand side is log 324 plus log 35 minus log 340. You can apply laws of logarithms. I can write addition as multiplication, division as subtraction as division. Here what you get? 5 times 1, 5 times 8. 8 times 3. So what is log 3 base 3? Same base, same number. We know that it's equal to 1. That's the right hand side. Now we'll take part D. So you have given left hand side and you are asked to verify this equation. So we'll take left hand side and simplify. LG 26 plus LG 119 minus LG 51 minus LG 91. How can I use laws of logarithms? I can multiply when it's addition. I can divide when it's subtraction. Now, how can I simplify this? I can see this and this. It's divisible by 17. 17 times 3, you get 51. And 17 times 9, not 9. What's the value? 17 times 7. 7 times 7, 49. 4 remaining. 7 times 1, 7. 7 plus 4, 11. So, 17 times 7 and 17 times 3. What about this side? It's divisible by 13. 13 times 2, 26. 13 times what is this one? 13 times 7. 7 times 3. So you get 91. So 13 times 2, 13 times 7. Now again I can see this 7 and this 7 get cancelled out and you get LG 2 over 3. Now we'll see whether we are getting the same answer on the right hand side. So what's the right hand side value? So what's the right hand side value? So right hand side is LG2 minus LG3. So here straight away you can use the laws of logarithms. So here LG2 over 3. Now we can see left hand side is equal to right hand side. Now we'll look at the last question in your textbook. So here you have given left hand side, all base A's. So you can simplify. So left hand side. We'll take this number inside. I can write log A base 3 squared. I can write 9 plus log A base 20 and log A base 36. Then apply laws of logarithms. I can write log A base 9 and 20 I can multiply and divide by 36. So what you get? 9 times 4, 20 divided by 4, you get 5. So you get log A base, what's the answer? I get 5. What's the other one? Now we'll take right hand side. What is right hand side? I get log A base 10 minus log A base 2. Subtraction I can write as division. So I can write this one as base A 10 divided by 2. So what is 10 divided by 2? You get 5. So here also you are getting log A base 5. So we can see left hand side is equal to right hand side. In this chapter, we covered all theory and examples and exercises related to indices and logarithms. So make sure that you remember all the laws of logarithms as well as laws of indices.